Sir, with your permission, shall we start, sir?
Madam, please go ahead.
Yeah. So, dear participants, it is my great honor to introduce Dr. PJ Kulkarni, sir, a highly respected academician with over 40 years of teaching and research experience in engineering and technology. Sir has also served in important administrative capacities, including and Deputy Director at Walchand College of Engineering, reflecting his strong leadership in both academics and institutional management. Throughout his career, his research interest has scanned computer network, image processing, and related areas. He has published extensively and earned the academic admiration of both student and peer for his dedication, depth of knowledge, and clarity in teaching. So we are truly privileged to have such an eminent teacher, researcher, and leader with us today. So let us all warmly welcome to Dr. PJ Kulkarni, sir. Now, so I'll request PJ Kulkarni, sir, to start this session, sir.
Thank you very much.
Yeah,
Thank
you,
you for the nice and a very crisp introduction.
Thank you, sir.
I understand that my voice is clearly audible to you. My screen is also clearly visible at your end. I'm just
Yes, sir.
confirming. Is it so?
Yes, sir. Yes, sir.
Okay. Very good. Good afternoon to all of you. It's always my pleasure to give interactive kind of the sessions in my delivery of this kind of the lectures. And I do expect that in today's event also will make it interactive. Do not blindly accept me on what I say. If you really feel you need to get some clarification, if you need something that you would like to add to, or if you have any difficulty listening to me or viewing my PPT, you can interrupt me anytime in between. Okay? I think my submission is clear. With this, I would like to really make beginning on the today's topic and going deep into it further. The topic title has already been disclosed. It is on the use of quality of data in AI and challenges ahead. Though I say it is more on quality of data, I mean to say on the quality of data in terms of reliability of data, in terms of making the data noise free, in terms of making the data contextual, and in terms of making the part of that data that we are making use of for a given context appropriate. And from that point of view, we would like to really make a move understanding the different contents in the entire session today. Along with this, I have a small submission to bring to each one of you. We are more from the academic fraternity, and thereupon, though we know more about the AI, though we use AI very frequently, the AI gadgets are all around us. And in fact, you must all be knowing that AICT has declared the year 2025 as the AI year, Artificial Intelligence year. Many initiatives from AICT have already taken place, and we need to be part and parcel in executing it. I am aware that this particular information of AICT declaration of making the year 2025 as the AI year has reached you, and you are quite aware of it. And with this as the small background, I'll be going forward, and I would be also making you much more understandable to the fact that these gadgets, which are all around us, which is all full with this AI, they need to be used very critically, because we are the teachers, we are the academic fraternity leaders, and many of us in the classroom, many of us in the laboratory, many of us otherwise also are looking at us that will be delivering to them much about the part of the AI. But when I say about much of the part of the AI, the applications of the AI, the understanding and proper use of AI would naturally be given to them. But what next? Are there any challenges in development of AI? Are there any challenges in the use of this AI? Are there any challenges in saying it that we use AI for providing a solution to the real life problem, but such a solution is not that is a foolproof. It might have something which might have not noticed by any one of us. Slowly, the one who makes use of these solutions will come across saying it like this, that there are some vulnerabilities, or there are some positive points, or there are something needs to be improved. I think this before we launch, this before we really go in for putting up this as a solution to the real life problem, we as a solution provider must be in a position to understand which are the typical repercussions on the solution that we provide using AI. And from that point of view also, I am looking up for some of those challenges, some of the ethical concerns, and few of those details which might not be giving you the foolproof answer to many of the questions, but naturally this will give you the way to go forward. At point of view, whole of this lecturing, whole of this session, whole of this interactive part of the session has been planned. This is the preamble for my today's lecturing. What is that I would like to cover up? We all know about this machine learning because data science has a component of this machine learning. Machine learning has a component of deep learning. And whole of that is what we say is one of the small components in the artificial intelligence. So without ML, I meant to say that this particular part of saying I have a machine with artificial intelligence is not true. We basically look further into realizing all those through a typical architecture, and that architecture is typically called as ANN, artificial neural network. This has a further extension to this in what we call the deep learning or deep neural network. We always question whether the machine is learning. Machine is always believed to be a dumb machine. Machine doesn't have any intelligence. Machine doesn't have any learning ability. Machine doesn't have any kind of a creativity. And still we say that machine is learning. So this seems to be something contradictory. So let us focus on this particular aspect and overcome the controversy that also will take up. And for doing so, many of you might not be so conversant with use of this AI technologies. Many of you might not be knowing the methodologies of this AI. Many of you might be little bit new to this AI, and to make them educate, to make them understand what is that I would be taking up further, I'll prepare a small introductory kind of the applications of what is that would like to consider this in the current lecture. This will be very easy to understand, and I would like to bring it to you. And this is typically focusing on this handwritten digit recognition solution. We'll port it on artificial neural network, or we'll make this available on a deep learning, or we'll call that this is available on deep neural network. Going forward into it, my submission would be to basically make use of a data that we make use of for training of the network. The network is the one which I say is the artificial neural network or the deep neural network. So for training purpose, we have with us a kind of the input which is a training input. It gets derived from the huge corpus of the experiences in the past. However, these experiences need to be encashed properly for the given context for which we would like to provide training to the machine. Having assumed that machine would have a learnability, machine needs to be trained. So when we look for the machine for its trainability, it needs huge experiences. Huge experiences need to be taken into account such that these are appropriate for the context, and there is nothing like a falsy, there is nothing like fake, there is nothing like something which is not acceptable to come in the training part of it. So this is where the kind of the quality of the data needs to be concerned. It is likely that the data that we take might not be so well understood by the one who is making use of this. And he or she who would be making use of such a data for training of the network would look forward for looking up very small intricacies, a very small micro part in the data which needs to be also trained. This happens to be the kind of the scenario where development and developer two of those will not allow anything to go missed out. So anything which is all available in the data needs to be taken into account for training. That becomes something what he doesn't want to lose. So from the developer's point of view, he also would like to see that which are those small critical points on the given data for which we must be learned. But it is likely that that small part that we are really looking for among that data, it might not be really related to any kind of a data. It could be noise or it could be something which is not relevant to the given context. So even if we look for getting the machine trained for the data which is not contextual in a small part of it, or is a noise, or is a sensitive but not useful for the current, I think we look for providing a training to the machine for its learnability, which is usually called as the overfitting. This also will look into. We would like to see that the training that we provide to the machine should be robust enough. Robust in terms of supposing a part of my processing for understanding, part of my processing for delivering of my understanding, which gets usually looked up in terms of predictions, estimations, or the recommendation. So while these are provided, I meant to say that when the predictions, estimations are provided, if some part of processing, if some of the parts of my processing or the part of my architecture is in some doubt or is believed to be something not working appropriately, this will naturally deliver a wrong output. We'd like to make our architecture, would like to make the entire process of making use of learning of the machine and going in forward for showing the learning of the machine in a foolproof way. And that's the reason that we would like to focus on the robustness. So what that robustness that we like to look at, either that robustness would be in terms of process failure in part, or it could be noise associated with the data at the input. And from that point of view, our training goes up. So training could be considered, naturally training has to be very thorough. And when I say very thorough, that under given a situation, it should not miss out any of the point. It should not really skip any of the point in the given data set to make it aware for the training of the given network. It could be in terms of the training of the network, which we call as a shallow training, or it could be hollow training. So we'll focus on these two parts also. And based on that, something is now coming up, and this word must also be put up in front of you by many of the social media. This is typically called the deep fake. We'll be also looking at what this typical meaning of deep fake and what it really puts some challenges in front of us. Looking for the continuing part on our contents, we would then go in for making our network, our deep neural network, or the artificial neural network to find something related to what is called the reinforcement learning. In the reinforcement learning, we would like to really model the critics, model the environment, model someone who is all around us. And we are going to satisfy the different objectives for them. Critics, environment, and whosoever would be looking up for this learnability of the machine will have their own ambition of what way machine should learn. And for that matter also, they would like to provide some input for this learning of the machine. So we'll look for this kind of those critics. From that point of view, you must have also come across another great buzzword, and that is a DeepSeek. I'll be focusing on the DeepSeek as one of the case examples in understanding what really actually taken up when the reinforcement learning is applied. There are many positive effects, negative effects, and these need to be also taken into account so that our development looks like that this would ultimately give up to the end user the benefits some of the disadvantages, or we may call that there are some of the limitations of our development, and for which the end user must also be apprised. And while doing so, the part on what I stated earlier is that the experiences to be encashed, data to be encashed, the input to be encashed should be very appropriate. If it is doubtful, naturally there is a challenge on the originality of that input. We'll have to focus on that, for which we'll have few case study examples in the present discussions also. Continuing the part of what would be the contents. It is likely that the data which I would be making use of to make it more appropriate for the given context, maybe for removal of the noise, maybe for adding a few of those things which are not there but are useful, we may manipulate on the data. While we do so, we also understand that data needs to be categorized, data needs to be classified, data needs to be appropriately taken into account for its end effect. So for the end effect, if it has got some multiple classifications or the categorization, is that the categorization that would like to look at the output of our work is also equally available in the given input? Is that all that categorization is equally likely at the input, or it is likely only in certain era and is not more likely in some other era, which indicate that the data is not balanced but is unbalanced, indicating that data which is getting used for training is not unbiased but is biased. And the meaning of bias is that it favors few of the categorization, few of the classification, and it is likely that few of the categorization being having a lower popularity in the given input gets a less focus. I think this needs to be understood while we select a data for training. I will be focusing more on that part. Security is the issue. Distributed data processing is also an issue because the network is becoming huge and huge, making training affordable, making this training as secured. I think that's another great part that we'll have to look into it. Ultimately, whatever that we really make use of for this AI for solving the real life problem needs to be looked up from the end user's point of view for its answerability. How good he will put trust, how good he will put a belief on the recommendations or the outcome that it gets from these AI gadgets. We'll have to focus on that. We'll do take up that particular part in detail. And for that matter, those different challenges in the development, all the challenges from the end user's perspective of its implementation, I think this will be all taken up. And the serious part at the end of it, that when we are really looking up for embedding this intelligence into the machine, which we say that this intelligence would compute with the natural intelligence or the human intelligence. In the computation part of this, artificial intelligence and the human intelligence, which I say is a natural human intelligence, we would like to see that, we'd like to really see to it that our ethical issues, like making this artificial intelligence for a proper cause and for a proper time, proper space, is not really overriding on the natural intelligence. It should not overpower the natural intelligence. And for that matter, we need to also take a few of the case examples. This is the one which is at the background. What I thought that I must bring it to you. You being the great educators, you being more from the academic fraternity, and you are working up as a teacher to the learners who are either new to the field or they are acquainted with the field, but you are there to bring to them on a very specific era during taking up this AI going forward. So for that matter, the quality of our training data, as I stated, which would also amount for making use of this for training of the network. Well, we look for the training of the network. We are thirsty enough in saying that training must be fast, it must be accurate. And from that point of view, there is another great balancing. We would like to see that the training is fast. And at the same time, we say that the predictions, the recommendation that we provide at the end of the training for its testing should be very accurate. I think these are those things that we would like to really focus upon in deep. Hope that This is my preamble, which would be really making you get oriented on understanding some of the contents in my current presentation. As I stated, machine learning is something which is really awful. When I say machine is a dumb machine, how can it learn? And today machine learning has become a buzzword. Is that the machine learning is something fake? Is that the machine learning is something which is not acceptable? Going beyond that, we also say that machine creates something. Oh, somewhere we find that human being could create something, but now we are making machine to create something. Is that the creation is at par with the human creation? Is it surpassing the human creation? What is all those things? I think we'll have to really put more focus onto it and get ourselves cleared on what is the meaning of machine learn something. Machine intelligence at par with the human intelligence is our goal. I want to say that it is our goal in development of those AI gadgets. So when I say AI gadgets, that artificial intelligence embedded in the machine is exhibiting the kind of that intelligence which would be considered at par with the human natural intelligence. Oh, so that being some of the objectives, we always compare the intelligence provided by the machine for creating some kind of exceeding the benchmark provided by the human natural intelligence. I think this is something that is always giving us how do we take our AI research to go forward. We'll focus on that. And at one time, you will come to understand that this machine intelligence or the artificial intelligence is exceeding the human intelligence. Of course, this is very contextual and limited. It cannot really take up this in literally as such. As we all know that the human beings would be more on this part of remembering, learning, applying, analyzing, evaluating, and then creating. Is that all these phases are appropriately also embedded into my artificial intelligence gadgets? This needs to be also looked up very, very critically. Now, when I say that we have those machines which have enough of the intelligence, it might not be fully at par with the human natural intelligence, but is trying to mimic the reality. It might add to the reality. It might indicate that this is a virtual reality, is an artificial reality, or it when it adds to that, it could be augmented reality. But these are all to be looked up in a very, very positive way. This is the where all those which are addition, which would be taking up its incremental development in a baby step, are needed to be understood very, very critically, which we'll take up today. So this part whereupon the machine's learning is all based on the training or the inputs to it or the experiences given to the machine or the manipulations if at all if it is needed in the training to be accounted and that too in a very critical manner. So these are all believed to be something in the artwork design of that particular machine. I'll take you to another black box concept about this particular artificial intelligence gadget. In fact, the typical popular architecture into it is the artificial neural network. We'll not go deep into it because this is not our subject matter of discussion. We consider this artificial neural network as a black box. We only understand that this black box gets some input, it delivers certain output, and what is there all within this artificial neural network is something which we could represent in terms of weights. What that weight is, it says it like this, given the input is multiplied by the weight and we produce output. Only that much of the knowledge regarding what is the functioning of the black box is presently considered. We do not go deep otherwise into it. So it says it like this black box, which is having artificial neural network architecture into it, accept the input, it modifies this input with internal weights and provide the output. That's all. We will not go much deep into it presently. This is not needed for that matter. But what is its input? The input is what we see and what the machine is going to see is different. Human being seeing the input and the machine seeing the input is naturally different. So we look for the input which needs to be represented to the machine in such a way the machine understands it. So machine would look to the given input in terms of a certain vector, certain quantities which are more in terms of computations. Directly computable part of the machine is now taken into account to accept the inputs. So let's take a few of those case study examples. So I'm looking for a kind of the learning application, which we say is a supervised learning application for developing something which is understanding handwritten numeric recognition, and it classifies that appropriately. So when I say that handwritten single digit numeral recognition has got many inputs, I say these are handwritten. I have taken up one such example. I write this one like this, or I might write the one like this, or I might write this one like this. Each of this is bit different. I say it's small difference with which is all written. And these are the styles of the individual person who writes it. But what I see to it that while it goes to the machine needs to understand this in the way machine could handle it. So what is that? So we convert the given input into machine readable input. And for that matter, the given input is looked up in a grid, which we say is a 4 rows, 3 column grid. So I say the 4 by 3 grid into which the one which would like to recognize is placed in. We say to it from the point of view of whether the one which we are going to understand, which is all there in this 4 by 3 grid, is occupying these cells, which I say is total number of cells are 4 by 3 equal to 12. So I have all those 4 by 3, I mean to say 12 cells, and the one which is getting recognized is placed into it. If this is so, if the foreground of the object of that recognition of that digit is being looked at, if this doesn't have anything occupied by the foreground of that digit, I call this as a 0. If this is occupying this cell either in the part or full, I call this is a 1. And if it is not there, again I'll say it's a 0. So accordingly, if I look for coding in this raster scan, this is the first row, this is the second row, third row, and the fourth row corresponding to 4 rows, which would have 3 columns in each of the rows. Am I correct? So I will take up this particular input to be represented in terms of a vector, which will have 1 by 12, 1 by 12 as the flat input. Why I say 1 by 12? It is basically 4 by 3, but this 4 by 3 when gets looked up in a zigzag scanning of it will give me as good as this is a vector which has got this 12 element components. And this vector of 12 element components, I'm saying it is simply 1 by 12. And how do I do it? 0 here, 1 here, 0 here. So first is 0, 1, 0, followed by, as we read, after the first row, we go to second, third, fourth like this. So 0, 1, 0, followed by 1, 1, 0, followed by 0, 1, 0, followed by 1, 1, 1. So this is my first vector, which is representing the handwritten numeral, which is called as a 1. But if I look for the different style, different orientation with which you could also understand that this is one. This is a one flavor. This is a small deviation from what I indicated over here. So in this situation, its representation would not really become 0, 1, 0, 0, 1, 0, 0, 1, 0, and it will be 1, 1, 1. The representation here for the same numeral is different than what we showed earlier. It is likely that there is another vital variation in giving up writing of this digit. So in this situation, this will indicate 0, 1, 0, 0, 1, 0, 0, 1, 0, and still this part is 0, 1, 0, which is all written here, which means that a single digit 1 has got 3 different variations, and these are called as the intra pattern variations. These are the variations within the pattern. Okay, but we understand that this one, which has got those three different variation, which is amounting for understanding a single digit, which is called as a digit 1, can have its component at the output among 10 different digits, and 10 different digits at the output. I know what are they? They vary from 0 to 1. I'm at 0, 9, 8, 7, 6, 5, 4, 3, 2, 1. So one of those 10 digit is the one which is getting picked up. Am I correct? In fact, I would put it like this, that I have in this particular situation that each one of this could also be represented in terms of another one-dimensional vector. So this one-dimensional vector will take into account 4 plus 3, 7 plus 3, 10. So this is what I mean to say 1 by 10. 1 by 10 is the vector flat kind of that vector representation that I expect. So my input happens to be this, but I want that output must be in this line in which the last bit of my that flat vector should be 1 because this relates to 1. So of all those 10 bits, only the last bit of that 10 bit becomes 1. So if this is so, for all the variations of these three, if this is getting only last bit as 1, I meant to say that I understood all the three variations to amount it for a single numeric digit, which is 1. I can take up this further and I can take up saying that what happens if I have a different digit? Let's say the digit is 2. When the digit is 2, this happens to be my coding 111, 101, 011, and this is 111. The intra-pattern variation, I mean the variation among the pattern for these two, say that this could be the different style for which my new representation of this vector is 111, 001, 011, 110. Or for the different other style, it would be like this. This will indicate 110. This will indicate 001. This will indicate 011, and this will indicate 111. Each one of these is different, a bit different. But now it amounts to recognizing at the output a digit, which is 2, which we will represent at last but one of this particular bit representation. If it is 1, this is for 2. Similarly, I can do this for 3. So it's the same way what I showed earlier, we'll have all those different variations for digit 3, but output here is for last but 1. So this is the one which is indicating digit 3. I hope this is a very simple, understandable case study example for making digitization of the handwritten input numeral from 0 to 9 and getting it inputted to that black box. Hope this is clear. You may interrupt me if it is not clear. If you would like to get something more from my end, I am here, but let's make it interactive. Is that I am clear to you? Is my appeal clear to you? Shall I expect any response from your end for this? Shall I expect any response? Shall I expect any reaction? I don't know whether I'm really
Yes.
audible to you.
Yeah, it's audible, sir.
Okay. Is this explanation okay?
Yeah, okay, sir.
Fine. So what is that I'm doing is like this, that I'm preparing experiences to be gathered. My experiences of understanding how do I represent 1, 2, 3, 4 like that to 0. And how do we really actually represent this at the output using these 10 different bins, 10 different bins for 10 parts of those digits, or I may look for the input, which as I stated is, though it is a digit, it is represented using 4 by 3 grid. So this has got 12 different such scalar values. So I look to this from I0 to I11, 12 different scalar values, or I put up this for its representation of output using 0 to 9, 10 different variations of output. And this is where I say these are my intra-pattern variations for called pattern 1. This is for the intra-pattern variation for the pattern called 2. And this is where I noted that this should have been is output representation. I could create likewise the input and the output map. These are all targeted output maps. Input and the output, these are all those which would like to really understand, we like to create. This is the essential part for the supervised learning. Is that a machine learning? Oh, naturally, that part has not been yet answered. We'll answer it. But for that matter, we create the experiences. And what I showed over here is the experiences to be gathered to provide it to the machine so that machine understand this intra-pattern variations for one, intra-pattern variations for two, and likewise are all the 10 different intra-pattern variations. But now the question remains. Now, this happened to be the intra-pattern variation for which I can train a machine if at all the machine is trainable. But what happens if I change the pattern? So the intra-pattern is only for one. I'll have intra-pattern for pattern 2. I'll have intra-pattern for pattern 3 and so on and so forth. But there's a great difference between a pattern 1 and a pattern 2 and pattern 3 and so on and so forth. And for each of the pattern, there are many variations. Look at this. Once again, I said that the pattern 3 has got 3 variations, which I indicated, but there could be multiple other. So the pattern 3 is believed to be different than the pattern 2. The pattern 2 is different than the pattern 1. And I would like to understand each of those patterns of 1, 2, 3 with intra-pattern variation for each one of these 1, 2, 3. I think this is something bit critical. Hope you are getting me in understanding the critical nature of understanding the intra-pattern variations. And then I can add what is called the inter-pattern variation. So not only that it understands this intra-pattern variation, but from pattern to pattern variation, which we call the inter-pattern variation, it has to memorize that part also. So how is that a single network? Artificial neural network, which is all housed into what is called the black box, is memorizing intra-pattern, so also the inter-pattern variations. And for that matter, we look into what is called as the learning algorithm in the black box. So what is that learning algorithm? It says it simply as stated earlier, it has got a known input, which is multiplied with the weight of the black box, and we create the output. But while we create the output, naturally this output is weight dependent. Input I cannot change because there is known input. Computed output has a bearing on selection of the weight, but I do not know how to select the weight. Let it be. So at the first instance, for a random weight selection, for a given known specific input, when I generate an output, the output will be also random for the simple reason that a weight is random. So for a given input, when it is multiplied with a random weight, output will be random. But we noted that for each of the output, what it should be, the one which it should be is called the targeted. So target output was also known to us in the supervised. So we created this input output map. So for the given input, what it should deliver as the output is also known to us. So this targeted output is the one which is taken up for providing an error between what is computed with this so that we get this targeted output minus computed output as the error. It is very natural that in the very first instance, when weight is not appropriately adjusted or when it gets derived from a random, the error will be horrible because this indicates that the computed output will not come to the targeted output. Targeted output is a fix which is all known to us, and a computed output is the one which is machine computed depending on the value of weight. So naturally the error will be horrible. I would say it is very high. Our purpose is to see that whatever we deliver as a computed output must be equal to targeted output. And if this is so, the error will be 0. And when I say that the error is 0, it means that machine has understood a weight for which the computed output has become something near to targeted output, and the error is either 0 or tolerable. If this is known to us, why not write the algorithm? We said that if error is 0, we stop or we continue for learning the weights. What do we do? So we select the new weight. New weight is indicating whatever weight we had to start with, we might have a random weight. So we select that weight. So this weight plus some constant multiplied by the error. Error already we computed. So some constant multiplied by error is the one which is added to this old weight and we derive a new weight. We do not know whether the new weight is appropriate, but we assume that this new weight is something. If I make use of the weight equal to new weight and go back over here, so with the new weight, I believe that for the same known input with the new weight, I find that the targeted output minus computed output will be better than the earlier. I mean, the error was earlier horrible. It will not be so horrible. It could be something tolerable, acceptable, something like that. Or it could go to zero also, depending upon the value of the weight it gets selected. Value of the weight gets selected here. Old weight plus C times error is the value which is new one. So if we do so, and we find that still the error is not acceptable or the error is not zero, then what do we continue. So whatever the error that we newly get, that error is multiplied by another, what we say the constant, whichever is we have selected earlier, continues to be used here also. And with new, what I meant to say that the old weight, which is not the random weight, I meant to say that this is already modified because of this iteration in the last one. So with which I get a new weight. I believe that this new weight when put over here in this one, new weight equal to weight, I find that it is likely that at least in the third attempt or fourth attempt or some attempts later on, this targeted output will be taking up this computer near to it and error will be zero, which means that I will find that this has to take place. This has to take place till the error going zero. I do not know whether error will really go zero. I do not know whether error will really come to zero with few such iterations. But I believe that error with this kind of a thing would be near to zero or it would be tolerable. If this is so, we are written here. If this is error is zero or tolerable, stop and understand what is the weight. So what is the value that we get, we learn it. This is how I say that my machine is learning. Hope the idea is very clear. What is that I'm doing? I'm applying the input. What that input is, either this could be the input for pattern 1, it could be the input for pattern 2, it could be the input for pattern 3, and for each of these, the targeted output is also known. Because as I stated earlier, all the input output variations are all with me, and this has all been well noted. So this is already indicated that for a given input, what it should deliver the output is known to me, which means that till the computed outcome comes to the targeted output, we will continue iterating it. And we find that fortunately to some time, some iterations after, we will find that the value that we get for a computed is equal to targeted and we stop. If we do so, that's a good part that we might have done it repeatedly for only one, which I would say is that for a pattern called one, because I might train it to this particular pattern. And then I move to this pattern for the reason that this pattern is different than this pattern, but output still remain the same. So whatever the random weight vector with which I started for memorizing it, for which machine gets learning, is applied for this new learning. We memorize with this new weight. This we apply for memorizing this. This is also small variation into it. These are all intra pattern variation. We memorize everything. And then what happens? It is likely that when I memorize this part for which the weights are appropriately adjusted, I might lose my attention memorizing this one, which means that after memorizing this, I must go back to this. I will re-memorize it. With this, I'll re-memorize this. With this, I'll re-memorize this. And again, at this point, not to see that I have not missed out any memorizing of this particular part, I'll go back, which means that after this, after this, after this, after this, after this, after this, I think all this after this will continue till I find that this is memorized, so also this is memorized, so also this is memorized by the single network, which means that all those weights that we are competing for memorizing, each of these are ultimately averaged, and that average single weight is memorizing all the intra-pattern variations. Am I clear? Am I clear?
Yes, sir. Yes, sir.
This is only one phase in which I
Yeah,
memorize
but
all intra-pattern variations for one. Then
yeah,
with whatever I learned,
participants,
so
please
whatever I learned
acknowledge.
for all those intra-pattern variations, I now move to two. So this is my 2 because my network remain the same. I do not have separate black box. I do not have many black boxes. So the same black box is made to understand the variation of 2. So whatever learning that I had for 1 is now applied for learning 2. With this, I go to learn this. With this, I go to learn this. But this might miss out the learning of this, which means that after this, I need to go back. And at the same time, I might look that this learning should not be at the cost of learning of 1, which I had taken in the prior earlier phase. Oh, that's another great difficulty, which means that I learn this from learning of 1, then I learn this, then I learn this, I learn all these parts as I stated earlier. And with this, I go back to see that I do not lose memorizing this part also. Oh, that's a great part. Iterations after the iteration. I look for memorizing the patterns. I look for memorizing the intra-pattern variations also. So there is the inter-pattern variation. So also the intra-pattern variations, as I stated, these are my intra-pattern variations all within, and inter-pattern variations is all among. So all these will get appropriately memorized. This will take iterations, not in terms of few. It might take it in terms of few hundreds, few thousands. But our aim is to see that the error must come to 0 or it must be acceptable. I think to that extent we do this. That the meaning I say that my ANN, which I showed you earlier, is something is the same architecture, but is understanding the different inputs for which I'm telling the output that it generates with the given set of weights is memorizing variations of the input very appropriately. So this is what I mean to say is my black box. This is really a magic box. Magic box. So what it would general be? So I'll just put more focus into it. Say that what is my input here? I say 1 by 12. What is my output? 1 by 10. So it simply says it like this. My input is 1 by 12, which is converted to output of 1 by 10. So what it should be, meaning that 12 input, 10 output, what it should have within this is only 12 by 10 matrix. This must be only 12 by 10 matrix. So 12 input, 10 output. So 12 input is converted to 10 output. But this is not so simple because the weights that we work on for each one of this into all inside is all taking into account all pattern variation, all intra pattern variations also. And that is where the training comes in. And that's the reason that I said like this. In theory, we can really show that my machine will understand this because we are making machine to understand. It's only iterative operations that go one after the other to make machine to average out something and see to it that everything that we would like to memorize is appropriately memorized. Machine memorizes it. And that's the reason I say that machine is learning. We'll not go deep into how machine really learns. It takes into account some theory from mathematics saying that error is to be differentiated with respect to weights. So dabba E by dabba W when equated to 0, I get optimal value of W. This is the theory behind it. We'll not go deep into it. So this part we skip. So we simply say it like this, that we know at our end error value, we know at our end whatever W that we computed. So when I look for dabba W by dabba error, which has taken into account this as the only equation, error by weight, because the computed output will be only because of this weight. So dabba E by dabba W will make me to see that this dabba E by dabba W goes to 0 for optimal computation of weight. This is how machine carries out optimal weight value. If it does so successfully, I say that machine learns. This is how we say that learning is embedded into the machine. For that, we need huge training data set. I said it like this, not only few. I said earlier intra-pattern variation of only 3. Why 3 intra-pattern variation? There could be 300 intra-pattern variations. Each handwritten digit will naturally have the same thing. It will be all different. So it has to understand all those 300 intra-pattern variations. It has to understand all those 10 inter-pattern variations. So that's the reason that I say that I have a huge data. I say that for the whatever data I have, I make use of 80% of that data for training and remaining 20% of the same context used for testing to see that my training is appropriate or otherwise. This has now become a very conventional. My data is in terms of megabytes. It is in terms of gigabytes. or it might be in terms of few terabytes. And I use part of that, as I stated, 80% of it for training and 20% for testing. And I carry out the acceptability of the learning of the machine. This is very, very simple now, which I consider as my foundation block in making machine to learn. And that the reason I stated that in theory and in experiment, what we get. So in the part where we are basically looking for the experiment, I find that the error variation is like, which is all having the bumpy nature, increasing, decreasing. But if I look for its profile, the profile is all indicated by this blue line. So I see to it that the profile is always decreasing. So with more number of iterations 1000, iteration 2000, and so on and so forth, the error will come down. And at some point over here, whatever value of error, if I say is acceptable to me, I stop iterations. And I say that machine learned. Am I clear? This is a very simple definition. This is simple implementation of the definition of making machine to learn. Okay, fine. Now here I have huge data, and if the data has multiple, I mean to say different ranges for its minimum to maximum, but my artificial neural network as a platform remains the same for many. I think this is not usually a good scenario. So instead of making my artificial neural network to change with the data, I'll make my artificial neural network same for any kind of the data. And I'll see to it that my data coming to it will be appropriately standardized or normalized. It is similar to what we usually consider in the database normalization. So we apply what is called as a data normalization. And with the data normalization, the minimum maximum bound of the variation of that input data is limited, it's standardized, for which a selected artificial neural network might work well. This is where we say that we are looking for the selected model to fit on the data, or we can say it other way, the data is to fit on the model that we have selected. What is the model? It is the architecture of ANN. Hope this is also clear to you. As stated earlier, say for example, I have a 10 digits to understand. And for 10 digits, let's say that for each digit, approximately, if I look for 100 variations, intra-pattern variation, so 10 into 100, there could be 1000 patterns I might get. But is that all 1000 patterns are equally distributed over all 10, 0 to 9, I meant to say? It might not be. It might favor more of 0, it might favor bit more of 1, and it might not favor more of 9, which means that all the 0 to 10 patterns are not equally likely in these 1000, I meant to say the 1000 patterns that we looked at. But how are the 1000 we worked out? We said that for 10 digits, each of the pattern might have 100 intra-pattern variations. So intra-pattern variations of 100 multiplied by 10 digits is equal to 1000. So out of this 1000, is that all the digits, I mean to say 10 digits are equally likely in this 1000? It is not possible, because this is all natural. And in the natural part of it, we can't really govern on the distribution of the patterns into it. If the patterns are not well distributed, if they are all skewed, it means that it is taken into account only favoring of few patterns, and other patterns are not at all favored or less favored. I think in that situation, it loses its identity in understanding, or it makes this understanding not deeply well understood, but its understanding is superficially. And possibly with this, the recognition, categorization, or output that we could get will not be accepted appropriately, because it has not been trained with a kind of a data which is unbiased. It got trained on a data which is biased. Biased data is one which said that the data is not balanced on all the variations. It is biased only on the few. Okay, so we have to take care. This is my quality of data. I mean to say, when I'm developing the machine for its learnability, the development of that learnability will come from the experiences at the input. And these experiences need to be scattered for different categorization that I look at the output. If there is no equal balancing of the categorization available in the input, output categorization is not well behave. Hope this is understandable to you. Under that situation, what then we do? Oh, if we understand that if they are not so equally likely, we create a data which would be artificially created data. So from reality, we move ahead and we create something which is artificial. So I have to see that we do not have a biased nature. We have something which is called the balanced nature of data. So we create something which is artificial. Am I clear? Am I clear?
Yes, sir.
Yes, sir.
So in the part of that artificial neural network, I haven't said what is all there in the black box. So what is there all the black box? Oh, this has got the input, this has got the output, and this has got many such which I could represent as in terms of matrix. I said only one matrix, 12 input, 10 output. A single 12 by 10 is a matrix. But in reality, the matrices inside this are huge. And for each of these, I might consider that there are number of layers. The number of layers are not only one, two, three like that. The number of layers that we could look into this black box is in terms of thousands. It is more than thousands. So the hidden layers, I mean the one which is not accessible either from the input or the output are all hidden layers. And they are not in terms of few tens, they are in terms of few hundreds, few thousands. And if I look to this in an architectural point of view, this is my input. I could scale that it is 1 by 12. Output is 1 by 10. And inside to this, oh, there could be huge number of layers, and each of the layer would have nodes. More the nodes, more the layer. Possibility is that I think of understanding many patterns associated with the input with no ambiguity for its categorization at the output. This is a very, very simple thing. This is what I say is all in my black box. Okay, this is my black box. So for that matter, as I treated that each of this round portion is indicating a neuron. There are thousands of neurons. There are millions of these links, millions of links. This is connected here, so this is connected here, this is connected here, this is connected here. Look at this. The links are also enormous. Naturally, each of the link will have a weight, so weights will be enormous. And for training of this, it will take hours. It will take months of duration. Oh, with which the computations are also very huge. So you involve the machine which will take up huge computation deriving this weight appropriately. I think such a great network is the one which I'm saying is my deep neural network. With this, I come to a typical another scenario, which is the great essence of my topic ahead. Let's take up the input and the output for this neural network such that this is called as a network typically labeled as an autoencoder, encoder and a decoder in fact. So what it says that we have an input which goes to my black box, which has got those weights, and from this we derive an output. And what is that we derive? What we derive is the same as that of what we was input. So my decoded output shown over here is equal to input or the copy of the input, which means that whatever I had the input is the same thing that I decode back. I do not know what is that really actually I do with this black box there. What are the input being delivered at the output? I'm not making any fun of it. But that's really is something that we'll have to look at very cautiously. What it says is like this, that this particular portion where the input is encoded and is coming up to a portion which is much less in terms of the data dimensionality. Here I have 5, whereas this comes only 3. I do not look what is this 5 and what is 3, but at least by looking to this kind of those black or the hollow dots, we find it that these are my neurons. These are my nodes. So these number of neurons or the nodes are much less than that of the input. Here I say that 3 and 5, it is not so much, but in reality, this could be in terms of few thousand. This could be in terms of only few tens. So few thousands, it converted to few tens. And then what do I do? And from few tens, I deliver it back few thousands because my output must be same as that of the input. I think the matter is very clear. Matter is very clear. So we are making up this something like called the 535 encoder. So 5 input is converted to through 3, and from 3 we get back 5. 535 encoder decoder network. So there is no fun right now, but now the funny part out of this will come next. What it says is like this. In general, in a digital principle, we noted that if I have M, I mean to say that M is the number of bits, the number of combinations with this I could work out very easily, and that is 2 raised to M. So I have a 3 bit indicate that 2 raised to 3, 2 raised to 3 is the number of combinations. Am I correct? So usually it gets governed by this equation called as if M is equal to log n to the base 2, my encoding and decoding is very appropriate. Encoding and decoding is very appropriate. In fact, what I need is that I need to have M more than this value. Say, for example, I'm interested in deriving, let's say, only 14 patterns. And for deriving only 14 patterns, how many bits I would need? Can I take up only 3 bits? If I look for a 3 bits, 2 raised to 3, 2 raised to 3 is 8. If I look for in place of 3 bits, 4 bit, 2 raised to 4 is 16. Now you tell me whether the 14 is accommodated in the 16 or 14 is accommodated into 8. 14 cannot be accommodated into 8. 14 can be accommodated into 16. And for 16, it needs a representation of 4 bit. And that the reason that 4 bit will accommodate 14 combination, but 3 bit will not have all those 14 combinations. Am I clear? Am I clear? This
Yes,
is
sir.
what we are learned in digital. But now in analog, in my this artificial neural network, it says that this particular condition is violated. M to be greater than log n to the base 2 is violated. And even if I get M less than this, I could work out decoding appropriately with no ambiguity. How it happens? So the magic is as follows. The magic says it like this. So for decoding what do I have? Supposing for 32 patterns, I need 5 bits. So 2 raised to 532. Am I correct? 2 raised to 532. But what is that I'm doing? I'm now saying it otherwise, that I would like to have 64 patterns. I would like to have 64 patterns. For a 64 patterns, as you all know, I need 6 bits. 2 raised to 6, 664. But I'll not use 6 bit. I'll use only 3. I'll use only 3. I know that with 3, 2 raised to 3 is 8. How can this accommodate 64? That's not possible. Really, it's not possible. But when it comes for artificial neural network does that magic. And the magic is simple. The magic is say that do not take up this 2 raised to something. In place of base of 2, change the base. So if I said that if I'm using only 3, so in place of making 2 raised to 3, if I make it 4 raised to 3, I get 64. Oh, great part. So this clearly indicates that I have with me only 3, but the best being not 2 but 4, I could work out 64 patterns. Look, this is the magic. So ANN does that magic inside. Are you with me? ANN is not all digital. This particular part of base chain is all automatic, all inside. So simply by making use of those 3 different discrete variations, I can have 64 combinations, which in digital is not possible, but under ANN is quite possible. Clear? I think with this background, going ahead fast would be easy for me. This is where I now say that autoencoder, which I just depicted, is learning anything. Is learning anything. Anything given at the input is compressed, decoded to a value same to that of the input, but via the number of bits which are much less, as I stated over here. So whatever the input, I route it through much less, but I still get it back. And that's the magic which I just proved. How do we do it? How do it is we are doing is also narrated briefly. And for that matter, I can say that autoencoder for that matter would learn anything. I mean to say for given input, it will appropriately decode, correctly decode at the output given the capacity. And what that capacity? Capacity is not governed by digital, capacity governed by that ANN magic, which I just put in front of you. Fine. So properties, besides the ability to copy its input to the output, I think this gives me a great another things to look into, which we say is sparsity. which we say is a small derivation from the given input. And this also we can say that if for a small derivation the input, if it gives me correctly, oh, look it from the point of view of input having a noise, and I could overcome the noise. Or input might be having some inputs which are not appropriately represented, and I could represent it. So these are those things which are not thought of, but now it gets thought correctly. What it means is like this. I have my input, which is called, let's say, 4, digit 4. I encode it, I decode it, I get back this, as I stated all earlier. So given the input 4, I get output as 4. Nothing new, because we already noted the magic this. So nothing new into it. But what I stated, we looked to it from the, we looked it from either a positive a positive point into it like. So let's say this is my table on the MNIST. MD dataset will provide you many such patterns. So we can make use of those patterns. I can make use of this as my artificial neural architecture, or this could be my deep neural network architecture. So it has got an input, it has got output. Input and output remain the same because I would replicating output same as that of the input. But I might have within the black box, this is my black box, many number of hidden layers, and each of the hidden layer would have many number of nodes. This is my deep neural network. Then what happens? I'm saying that this is with a small code. My input is something which I would like to take up to go to the output through many hidden. At the end of this, I get this through a small code, which I meant to say is a encoded code of 32. So 784 through 128 hidden layers is simply compressed or encoded to 32, and from 32 I would like to get it back to 784. I might use up this different architecture, which is saying that I'll use a sigmoid function of neural network. I'll have an activation function of ReLU. I'll have many such hidden, and so on and so forth. With this, I would like to take what way output is to be measured for its comparison with the base. So here I'm making the binary cross entropy because I'm looking for categorization or classification, which is all discrete. So binary cross entropy is much more valid for taking up the categorization which is discrete. And I make use of this. And while I really code my ATAL encoder, how I do it? The fitting here is my input is, which I say is the X-train. But what is my output? Output is also X-train. So my input, which is a training, is also what I look for getting it at output. And I would like to do this using epochs of 5. Each of the epoch might have hundreds or thousands of iterations. So 5 epochs is not 5 iteration. Each of the epoch inside to this will have number of iteration. The epoch says that the entire set of data is used at once for training. But in each of these, for intra-pattern variations, it might go for multiple within iterations, and this would be all adding up to those total number of iteration. And that's why I say that epochs will be now put up in terms of epochs. Each of the epoch will have multiple iterations. So at least I carry out the 5 iterations for the entire pattern. So entire pattern, let it be intra pattern or the inter pattern. So all these are taken up and I go through this at least 5 times. So this indicates epoch of 5. And for that, if I really train the network, this becomes my architecture. 784 nodes, 128 next node layer, 32 is my code, which is at the innermost. Then in the decoding part, the same what we use at the input will come over here. So 128, then 784. Why it is so? Because I already indicated, no, whatever I have over here, which is a part of encoding with Deleuze's code, should be inverted here. So this part and this part are complementary. And likewise, this particular code does this. With this, what I get is like this. The model fitting is done for input, which is a training, which will also deliver the training part at the output, which means that whatever I accept as a training is the same thing which I accept as the output. Now the part comes, which is very interesting. And this interesting part is saying that we would like to train the ATO encoders. How do we do it? As I stated, number of epochs, each of the epoch will have number of iterations, and we do this at depth and see to it that we get correctly. So these are some of the result of the sample data. So I get the input like this, I reconsider the output like this, which I believe that the part of input and output is more or less similar. more or less similar, except for somewhere here, I find that this is not so acceptable because it's not identical. Otherwise, it is all acceptable. So in this situation, I go ahead, I say that my input is having many of those handwritten numeric. When I reconstruct this using the autoencoder, I could get it like this, which means that it has become bit noisy because the training is not complete or otherwise. It is likely that I may look at it otherwise. That purposefully the given input, which is a noise free, is corrupted in noise. I get an input which is noisy and I put through this encoder decoder. So my decoder must give me the same thing. But what I say, the decoder must give me back the original. So encoding is done for noisy, but decoding is done for not a noisy. As I stated, auto encoded don't going to learn anything as I stated. So input is noisy, output is not a noisy, and it works well. It works well. As I stated that. So this becomes a noisy, and what I get at the output after iteration, epochs, is this thing which is near to that of my original. Oh, that's a great magic we worked out. We worked on. So this is then called the denoising autoencoders. These are the basically called the denoising autoencoders. And with this, we get to have another great idea. And these ideas are like this. My original input is like this. Purposefully, I make it noisy. With this noisy input, I apply it to my encoder, which will give me back at the output something which is like this. Okay, so this is the idea with which I'm making going forward. Just a minute, just a minute, just a minute. Extremely sorry for the interruption. Let me go ahead. So as I stated, for a given noisy input, I expect back the image which is noise free. Oh, this seems to be not so innovative, but innovative part comes like this. So which I put up this in terms of sparse autoencoder. When I say sparse, it means that purposefully in my encoding decoding, few of the nodes, few of the hidden layers are purposefully deactivated. When I say they are purposefully deactivated, they are taken out from learning. They are taken out from learning. This clearly indicated there is a fault in processing. But as I just stated, that when my input is a noisy, output can be made noise free. Now I say it like this, in place of making input noisy, I'll make input noise free, but I'll make my processing noisy. And to that also, I would expect output to be noise free. This is something we call as a magic. So this is the principle of sparse encoding. So what I said earlier, the input is noisy. I can think of output noise free. Now I make input noise free, but I'll make my processing noisy. Still, I expect output to be noise free. Am I clear? I think if this is going to give me a good result, I look to this from different another angle. And one of the angle into it is what is called as the putting input with bias. So I'm purposefully creating a bias with the input, which is now popularly called as a deepfake. This is popularly called as a deepfake. So what is that we do? We create the input, which is not a true, but we create a fake input. And as I stated, my autoencoder is going to learn anything. So I give input as a fake, but I expect output to be original. Are you getting me? I give input, which is a fake, but I expect output to be original. And I notice that autoencoder does it. And that's the principle of what we say about the deep fake is based upon. So it manipulates the facial appearance of a person at the input, but at the output, I say that, oh, this is the original person. It is not the original. This is all coming because of that manipulation of the facial at the input. So deep fake leverages the powerful technique. This is where we never thought of. And that's I said that I'm now moving into the innovation. So with this innovation, I put purposefully something which is fake, which is not true, and I expect to get from this something true. We never thought of this, but it now works. It works. And this makes use of that auto-encoder principle. What it says, oh, this make use of toxic contents of the input. Toxic, I mean to say, not acceptable kind of the input. And it says that, oh, this is converted to acceptable. Not acceptable is converted to acceptable. So data in original or the natural form to be most protected and valued. If it is not protected, not valued, anybody who is looking to it from the hacker's point of view can manipulate the data, and for the manipulated data also he can think that my output is correct. Why say so? Because that I just indicated. This is something is the manipulated data, and even for the manipulated data I could get back to the original. Okay, this getting trained on the autoencoder, I look to this from the crooked way, and that's the reason that this deepfake has come. Deepfake has come accordingly. Look at this. These images are not those original images. One image superimposed with another, and I create this kind of illusions that it looks like the original, it's not exactly original. I consider these. These are all those images which are not true images. None of the image really belongs to any of the human being who is alive. I mean to say, it is none of those which are for the real right images. These are all fake images. Fake images. How are they generated? As I stated that I have one image which gets mixed up with another image. I'm interested that these are those things which I purposefully make use of in inputting, and I generate from this something which is like this. And such a one which I just stated is not going to have anything to relate with any one of the original input. This is my original, this is my original, but my output is not related to any one of this directly. Indirectly it relates. But this is a fake image. This is a fake image. Okay. So we can look to this from the positive angle, and that's I say that is the right cause. Right cause use it like this, that we can use this for training on the hours of footage on the target, which I'm looking to it in a right cause. This would minimize the training data and time to train the model. For example, look at the scenario where you are supposed to drive a four-wheeler car. You are a learner for this four-wheeler car. In the ancient days, we used to actually physically drive the car. And while driving the car, we being learner, we are likely to make any accident, something like that. And these are also in the sense that this is a physical damage, which is not acceptable. So in place of making a learner to actually physically drive the car, why not allow the person who is a learner to drive a simulated car? So in that simulated car will have all those simulated images. As I indicated, these are all simulated. These are not original. These are all considered to be fake, but not that fake which is not acceptable. It is acceptable because they are near to real. And we get trained into it. And once we are trained to those images which are near to real, we then experiment on the real. Naturally, in that situation, moving from near to real would be easy, and it will not be so cumbersome in terms of any kind of a physical damage. So this is the right cause. This is definitely a right cause. For example, supposing I am making use of my own recordings on the YouTube, and my camera has captured along with my original video some kind of a jitter, some kind of a noise. What do I do? That noise is something which I can overcome, because given the noise, how to overcome in the part of that auto encoder we have seen. Why not use that auto encoder to overcome the noise? Great part. If at all I am having some occlusions, I am saying something, but I am moving my head, I am moving hand in between my head and the camera. So there are some occlusions. So I notice those occlusions, which I consider is a part of a noise. Can I overcome this in autoencoder? 100% I can overcome. So this part is something which I overcome, and I get the output which is noise free. This is something which we never thought. These are something which I say the novel part, and these are novel temporal coherence that would like to make use of for the right cause and make this deepfake work rightly. Methodology, as I stated, is an autoencoder. So deepfake encodes those images which will make use of the feature space contain key features of it. I might change the facial features, but this is done all for the right cause. And we would like to do this for the simple thing that it makes me to take something to the end of it via a media, via a route which is more acceptable and feasible. Okay, as I stated, simulation is more acceptable than the actual. So I do that. I generate those networks which are all creating those scenarios. I call these to be GAN, generative adversarial networks. And they would come up in place of providing the actual training. The training would be provided by this GAN. So this GAN would train the decoder. And this is where the adversarial relationship will come forward for a positive cause of making this application work. We can create images, videos, audio for that, and would like to mimic the reality. I'm away from the reality, but I'm mimicking the reality. This is what I meant to say artificial intelligence. This is where we are mimicking the reality. We might not have a perfect copying the reality, but we are near to the copy of the reality. The research. The research then says it like this. We go in another way. We create defects. Defects are big business opportunities. We create something. I'll indicate to you this particular part. A Japanese company called DataGrid, it created a full body deepfake. What for? Oh, this is just to propose this for a demonstration during a tutorial work wherein the person gets worked out from the scratch, and it could be intended for its use in the fashion, apparel, or for medical training. I think for the right cause, this has been used, very good, well accepted, really well accepted. I think other part, which is also negative, is all known to you. Saying it like this, that we show a picture, we show a face of a person, which is not a true face. This is a face which is manipulated, but we pose it that this is the truth. And the one who is educating, the one who is learning, he doesn't differentiate between the fake and the original. He might get that fake as the original, and that creates a danger. That really creates a danger. I think these are the other challenges that we'll have to look at. Okay, another challenge is like this. We take up the new scenario. There's another innovation. We look to it from the point of view of providing reinforcement in learning. Reinforcement is improving on the learning. And when I say it is improving on the learning, I meant to say that the improvement in the learning comes because of the external environment. So here the environment is training this learner. So this is my black box. The black box will get the input in general. It will deliver the output. And this input output is also looked up by the environment. Environment is not a trainer. In fact, what I would say over here, this is supervised, but there is no supervisor, there is no teacher. And when there is no teacher, the training would go in a wrong way also. So what I do, in place of actual trainer who would be costly to provide the training, I deploy environment, I deploy a critic. So critic is the one who doesn't know how to train, but it simply looks for a given input, what it should deliver as an output. To get to that output, what it should do in the magic box is not known to the environment. And for that matter, it comes up like this. It has got a different randomness, as indicated over different randomness, but for all those things, it simply says it like this. If for a given input or anything called the input, output is correct, it rewards. If for a given input output is not correct, it provides the penalty. So this is basically a automatic, or we may say associative reward penalty algorithm. If the output is accepted and it delivered, it is given the reward. If output is accepted, but it is of other nature, this is to be penalized. So these are the only two things now needed. So there is no supervisor, but this is taken up by something which is called as a critic, who is less in its cost, less in effort, and easy to work it out. And for that matter, this poses a problem. And this is typically called as a credit assignment problem. What it says, the environment or the one who is providing the critic doesn't know how to make it correct for wrong thing, but it knows that what is correct. You must be knowing a critic always does it like this, saying that, oh, what you are doing is not correct, or what you do is correct. But if he says that what you are doing is not correct, if you go and ask him, tell me what way I make it so that it will be correct, a critic doesn't know. Critic really doesn't know. He simply puts a critic. He doesn't know how to make it corrected. Okay, so from that point of view, this credit assignment problem in the reinforcement learning says it like this, that I need to identify from my that black box, which is all having those number of layers and number of nodes in each of the layer, to correct them. How to correct them is not known to the environment, is not at all known to the environment. So what happens? So what happens in that situation like this credit assignment problem says that to whom, to which layer, to which node we should provide the appropriate learning. That is not known. So what we do? So what we do is like this. So environment doesn't provide the input to the learner. It provides input to the learner via another. And who is this another? Another is something which is called as the expert. And the expert understand the environment, expert understand the output of the learner. So what it does, so it provides here something which is called as a signal, which is all usually taken up by the environment to provide it to the input, which is all in terms of you do correct or you do not do correct. So likewise, it generates another architecture. This is another deep neural network architecture in which this model is trained to exhibit the performance of the environment. So given up the input of the learner, given up the output of the learner, and given up the way environment functions, everything is all now made known to the model. Model will generate R. This R is the one which is similar to the R, small r generated by the environment. Now this R is never used. This small is also never used. But because of this, whatever changes which is all required to be carried out within the neural network as the error is passed on to the learner. Earlier, error signal was not available. Error signal was available directly from the environment to the input in terms of what you do is correct or what you do is not correct in terms of reward penalty. But now it will be routed via the model, and model will take it in a detailed error fashion matter to provide input to each of the node, each of the layer to correct it. This is the reinforcement learning. I think I have created a very good background. With this, what is that I'm doing is like this. We propose another, which is all you know about the great innovation Chinese made so far. So they call this new innovation under the title called DeepSeek. DeepSeek. DeepSeek R1 is one which creates the kind of this particular model. So model is the one which is all getting the appropriate training from the environment. So there is nothing like the actual, there is nothing like heavy, there is nothing like not affordable model for training the learner. And we make use of this and we train it. We train it. It works very well. This is the DeepSeek. So instead of making use of only one expert to train the learner, why not we make use of number of experts to train the learner? So that is where I go back and I show it over here. Here I showed that there is one model and this model is training this learner. This is my black box. So black box is getting learned because of this model. So if a model is learning this particular learner, I think this would have a limitation. Why not we have multiple such models? So the model is in engineering, model is in medical, model is in law, model is in commerce, model is in business. For each of these, we have a different model. And depending upon the kind of the input, the model is appropriately selected and the training is provided. I think that's a great idea. And if I see that if this is really a great idea and DeepSeek gives me a good result for this, this is now newly called the mixture of experts, MOE, mixture of experts. So I make use of number of such experts to train the learner, train the magic box. And with this, when it really works, so the operations are looked up in a positive way as follows. One is called the distillation technique. See, please look at training is costly, as I said, But when I start training right from the scratch, the training will be definitely costly and will be time taking. But if I start training from something pre-trained, if I start training it with some base, possibly training would be faster and it would be affordable. So this is where the distillation technique would come in. This will reduce the training cost, which means that I'll make use of the expert who is in medical. He is training my network. But when I'm looking for making use of this learner, not for medical, but let's say for a sub branch in medical, which is called a homeopathy. I know that the medical expert has provided a good, but homeopathy part of that is not been done. So I'll make use of the learner, which is my black box from the medical, and for fine tuning, I'll go for homeopathy. I think in that situation, training this network right from the scratch to homeopathy would be difficult. But if it is trained for medical, making it fine-tuned to homeopathy will not be difficult. So this will have a reduced training cost. It will be affordable in pricing. And these things are currently all available in what I meant to say is that DeepSeek. DeepSeek does it more than what you could see in Chat GPT, which is more like a closed source. DeepSeek is not closed. This is all open source, and you can definitely make this much more affordable because this is freeware and this is not requiring you to subscribe for. This is 100 to 300 times cheaper than the OpenAI Chat GPT. Of course, we do not know what way this has been made so open and free. This is all coming from Chinese kind of those innovation platforms. We actually do not know what the purpose is. But presently, we see to it that this is also open and could be made use for positive cause. We definitely make use of this for a positive cause. With this, we come to the challenges which I just stated earlier. The deepfake. Deepfake gets misused to generate blackmail materials, because this is all indicating that what I inputted for training is a fake. So this is a false increment. This is something called the victimized kind of those inputs which were taken up, and we are going to pose it like this is the original. Fakes are not really distinguished from that of a genuine. And for the one who is a learner, he cannot distinguish. Deepfakes, for that matter, gets misused. They get misrepresented. And you must be knowing for many well-known politicians, their videos are deepfaked. Deepfakes used for creating digital actors, and this could be considered positive or negative. The actor is deceased, actor is no more. But you can create a new movie with a deceased actor. Because as I just indicated that we create the training material, which is all derived from the original, but is presented right now in a fake manner. So that fake is near to original, near to but not real. Okay, so these are some of those challenges where DH characters could be put on the screen once again. It could be positive, negative, but this is a challenge. Okay, we look for the challenges ahead. These defects would leverage to defame somebody, to create something which is not natural, but in a fake manner, showing it that this is the original. It would spread this information, which is basically disinformation. This would not be considered no longer valid, because this comes to you with many different media, and tracing back from which media you got it would also become difficult. So it becomes difficult for matter. Twitter and Facebook are presently engaged in understanding out of many things that gets created by these artificial intelligence magic boxes, which could be considered original and which is not so. I think Twitter and Facebook, they also suffered a lot in their endeavor, and now they took a stride to see to it that what gets generated through these social media using these black boxes or the magic boxes to be understood whether this is really original or fake. So that project is going on. DeepSeek challenges. So we said about the deepfake challenges. Come to the DeepSeek challenges. The ethical implications. I think wherein I just stated that we make use of the training from expert. We do not know who that expert is. If expert happens to be fake, if expert happens to be biased, if expert happens to be something which is not truthful, oh, it will create havoc, because a truthful expert is training a network, and training network doesn't know whether this is truthful or otherwise. We believe only on the outcomes from the network which is learning, and the learning network, because of the biased learning, provides the kind of the output. If it gets accepted, there's a great havoc. So these are the DeepSeek challenges. You must have also noticed this through social media that DeepSeek, though is so popular, it has got many those, what I could say is a hidden aspects into it, which create a great challenge in front of the society. We'll have to look to this in a very positive way. So also we need to be very cautious in making use of this. But the positive way of this is, as I stated, that this is a good one for making use of this for pre-train. So instead of training the network right from the scratch, we put it through pre-train. So we make use of one expert which trains it, and we make use of another expert for fine-tuning it. So this is incremental, this is affordable, and this is fast, and is believed to be more accurate. For that kind of a thing, this is very good. And the ethical implications part of it, I'm saying it like this, that this would naturally give me a positive way of going forward. But otherwise, as I indicated that there could be falsy and there could be a fake thing that coming while training is provided. So we need to be cautious. As we all know, supposing we all know about that Elon Musk car, which is all driverless car. In a driverless car, the car gets driven by the machine only. There is no driver inside. And such a car, if it meets an accident somewhere, if it comes across any accident, we do not know whom to hold responsible. Is the driver to be held responsible? Because there is no driver. Is the passenger is to be held responsible? Oh, it cannot be. Is that the developer of the system to be held responsible? I think these are all those, from the ethical point of view, the questions are not yet well answered, but these are those challenges. I mean to say it like this, in the data which is basically used for training of the network, the quality of that data, authenticity of the data, reliability of the data is matters a lot. If we do not trust and if we make use of this for training, I do not know what are the repercussions of the learner based on that. We need to be very cautious. Data quality in the data science for that matter is utmost important. I believe that the responsible, authentic, ethical and reliable AI applications will need the quality of our data. It needs to refine the quality of the data. It needs to prove the authenticity of the data. It needs to put more of that credits on the data, which it says is the reliable. If we do not do this, oh, possibly during learning, during providing all that education to the students or those who would like to get from us, and if we do not put that particular kind of those inputs which are to be accepted with a great cautious, I think we need to refocus, not twice, thrice, but for multiple times and get it clear that what we do is all ethically acceptable. I think with this, my message to you is very clear that this research would continue to reach to the better heights, provided we make use of these gadgets for its appropriate use by taking into consider the ethical aspects of it. Hope this is acceptable to you and you like this the presentation. I though say that you need to interrupt me in between. I could not find any interruption. I could not get any kind of the intervention. It was a kind of a one-way talk only. However, I stop over here and I would request you to ponder few of the questions in front of me.
Yeah, thank you, sir. Thank you. Yeah,
Any
dear audience.
questions?
Yeah. Dear audience, if you have any doubt, you can raise question. Please raise your hand and unmute yourself. Hello, am I audible, audience?
Yeah,
Dear
yeah.
participants, yeah, please.
I must get few of the queries. I must get some of the suggestions. I'm working in this field for last many years. Your small input to me will help me a lot. If you have any difficulty understanding me, you could also get that difficulty cleared. Do not blindly accept me is what I appeal to you at the onset of my starting of the lecture. So please use this appeal rightly. Hello, there is a
Yes.
100% silence.
Yeah. Yes, dear participants, if you have any doubt, you can raise.
I'm saying it other way. If you have doubt, it's not correct. They have to have a doubt.
I think there is no.
Okay, no problem.
Any
Hello.
My
response. Yeah.
email has already been given.
Yes, ma'am. Yes. Yes.
Uh, um,
Go ahead.
Go ahead, please.
Hello.
Yes, Trupti madam.
Sir. Sir.
Please go ahead.
Huh. Sir, you had shown one diagram that, of wherein you uh, check for the noise
Okay,
in the processing. Sir, can you just go to that slide one more time, please?
definitely, definitely. So these are the noisy inputs. This could be another which you might be looking for. Tell me
No,
what
no,
is
no,
that
no,
one?
no, no. The block diagram. Huh. Before this, before this. No,
This
before
is
this
a
also. Sir, see, why I'm asking is because I am working on skin cancer images.
okay,
Okay. So in that case, what is happening is I have an image with me, but for skin cancer, I have to clear I have to focus only on that pigmented area. But on the
okay,
skin, we have hair, okay, and other
okay,
marks, okay.
okay,
So I need to design filters and I need to use techniques to remove all those defects or
correct,
the features that are there in the skin.
correct.
So, but what is happening now, when we are trying to work on it, me and my students, we are kind of losing the data also in some cases because the tumor is not very well defined. So,
I
in that
suggest,
case,
I
can you
recommend,
suggest, huh?
I said the same. Listen to me carefully. I
Huh?
suggest, I recommend into that event that the
Huh?
conventional techniques of pre-processing the image, the
Huh?
conventional technique of understanding the features, conventional
Hmm.
technique of deriving the feature was all there. However, if you have the image sets with you, which
Hmm.
is indicating which part of this is an artifact, which part of this is a tumor, which part of this is to be removed, you can make use this for training. So there is no need for you as a human expert or a programmer to derive features from the noisy image, which is a cancerous image. So we do not look for effecting, or we do not invest our efforts which are
Hmm.
so costly because it needs human expertise, it needs huge time, and it needs huge programming
Correct.
efforts. We don't
Hmm.
need anything of this. We don't.
Okay.
So
Hmm.
please see to it, we need to have only the data set which will indicate the image with no hairs, image with no artifacts, image only with cancer, only with something which we want, or only something which we don't want. We make use of all that, which is all contextual for training of this network, which I say the autoencoder. However, in each of the situation, again, I'm saying it like this, whatever I'm going to declare as identified is known to me from the previous experiences. I'm not creating anything fake. So previous experiences showed to me that though there is a hair, though there is some artifact, the basic part of the tumor into it, which is a cancerous, is well identified. Am I
No,
correct? So
that
this
is
is
the whole
known to
problem.
me.
Yeah.
That is
No,
known
no,
to
no.
me.
That is the
One
okay.
minute, 1 minute. Please listen
Huh.
to me. Please listen to
Hmm.
me. Please
Hmm.
listen to me. I am saying that I have with me a kind of a data which say that which to be labeled as a tumor, which is all benign or not a benign. Am I correct? It's all known to me first. And then I'm going to apply this to the unknown. Am I
Okay.
clear? Whole of our
Okay.
journey
Okay.
is
Huh.
like this. We first get
Hmm.
ourselves known to what is current scenario. And then we apply to unknown. Hello. Hello. Am I
Huh.
getting
Yes, sir.
you?
Yes, sir. Yes. Yes. Yes, sir.
Please listen. Please listen to me carefully. I have with me 100% data in which it clearly indicates which is the part which is cancerous, which means that the identification has already been done. Are you with me? Everything is done.
Yes, sir.
The noisy data, not a noisy data, cancer data, not a cancer data, artifact, not artifact, everything is there and everything is labeled, everything is known to me. With which what I do, I select only 80% and 20% I reserve for testing. Am I correct? So from the
Yes.
80%, wherein I never imposed, I never used, I never invested any cost on feature extraction. I never invested anything on the pre-processing. I never invested anything on programming. I used it as it is for training the network. Are you with me?
Yes, sir.
In which situation, the labels which are already known are getting used for training the network, which says that the network is well trained. network is well trained. I am yet saying it, please understand. I do not focus on what is cancerous or what is not cancerous. It is not known to me. It is not required to be known right now. So out of 100%, only 80% at random are selected for which the network is trained. And the remaining 20% for which the label is also given, for which the label is also known to me, is now used for looking for whether my training is correct. If my training is correct, if it is found that in testing, then what do? The 100% data that I have is now thrown away, is not taken out. And now you go for your own data, which is cancerous, which is believed to be detected for cancer. Are you with me? Am I getting you?
Yes, sir. Yes, sir.
So under that situation, under testing, when you understand that your training is correct, testing is also correct, you throw away that data and you take up your own data, which is needed to be identified, which is needed to be categorized, which is needed to be classified. But the new data should not be altogether different than the training data. It should be similar to it. Are you with me? That
Yes,
does the
sir.
job.
Yes, sir.
That
No,
does the
no.
job.
Okay.
I said
Okay,
that
sir.
does the
Thank you.
job.
Okay. Okay, sir. Thank you.
That the reason? Let me listen to me carefully. Listen it very carefully. We do not invest much on feature extraction. We do not invest much on programming efforts. We do not invest much efforts on anything other than training of the network. And training of the network is not that it is laborious from the human side. It could be laborious from the machine side. Machine would take possibly 10 hours. It might take 100 hours. It is for the machine. Machine gets trained. And a trained search machine can then be used for testing, which is unknown. Am I clear? If the results are not acceptable, because to see that whether the result is acceptable or not acceptable, you need to involve human expertise. If the human expertise said that what machine said is not acceptable, machine will ask that expert, tell me what is not correct, which is now used for retraining of the network, which I said is the initial training will continue. Last of the training will continue. And such a trained network can be then used for identifying something which is unknown. Am I clear?
Yes, sir.
Yes, sir.
Yes, sir. Is.
The one who asked the question now silent. Still,
No,
if you
sir.
have any
I'm
doubt,
there. I'm very
please
much
raise
there.
it.
If I unmute, there will be background noise. That's why I've muted it.
Am I clear to you?
Yes, sir.
Fine.
Yes, thank you, sir. Anybody? Any question from audience?
Yeah,
Madam,
hello, am I
madam,
audible?
Yeah, yeah. There's
madam, hello. Please communicate to all the participants that
okay.
this kind of pre-training of the network, deep learning used for estimation, classification is not to be accepted immediately. It needs to be accepted with great validation. Our conventional technique of machine learning, our conventional system of pre-processing, our conventional methodology of feature extraction, these are 100% valid. But to get a cut shot and a fast and accurate, which was my one of the premises in my discussion, we look for this kind of a deep learning network to be deployed. Am I correct? So do not
Yes.
consider a deep neural network is replacing everything. And that's why I said that AI is to be used very cautiously. It will assist you a lot. Okay. Slowly in the year, possibly that AI could replace human being for many of the tasks. And this is not too far. This is all happening today also. Okay.
Yes, sir. Definitely.
Thank you.
Yeah. Any question from audience? Is there any question? So thank you very much, Dr. PJ Kulkarni sir, for your insightful session on data quality for AI. You're
Hello.
highlighted with yes.
Yeah, am I audible now? I'm
Yeah,
sorry, I
okay.
was thinking coming through, and I wanted to ask one question.
Yeah, okay. Yes, ma'am.
Yeah, so my question was that I am actually working on fibrosis using the transcriptomic data. So in that case, there are large data sets. So for that, I would like to understand
Your voice is interrupted. I can't listen to you now. Please make sure that you are audible to me.
Yeah, madam, check your mic.
hello.
Yeah.
Hello. Hello, madam. Please come up once
Yeah.
again.
So yeah, so actually I'm working on fibrosis and I'm working dealing with this transcriptomic data. So I'm dealing with the large data set wherein there are genome sequences and there are other features. So while pre-training that model, I'm using TabNet model, uh, which is of semi-supervised model. So can you just suggest me that whether to use semi-supervised models in this cases for pre-training the model just to get the embeddings, and then based on that I want to fine tune again model for prediction.
100% that is what I said in DeepSeek. Have you listened to me and DeepSeek?
Yes,
I gave a very
yes,
detailed
sir.
description of DeepSeek is for mixture of experts used for training the network.
Mhm.
Already I said is a reinforcement learning. What you say is a semi-supervised, is a reinforcement learning. So I pre-train it using mixture of experts, and finally I take a default training using conventional. 100%
Okay,
valid.
okay,
That's the
sir.
reason that I focus on this in detail. That's why whole of my discussion in front of us using only small baby steps. I started from the scratch and I take you to the higher level. So my submission to you is, again, I said the one which I need to reproduce here. Please see that our conventional means of machine learning, in which we have a pre-processing, we have a feature extraction, we have appropriate training based on the feature, is all 100% valid. However, to make a cut short into it, in terms of processing, in terms of improving the accuracy, we make use of pre-trained models. Not that every time we need to go for a training of the model right from the scratch. So pre-trained model using that DeepSeek is one such option that already I stated. So having noted the DeepSeek, which is having that mixture of experts for training, you can make your network for final training. GPT basically says it like this, is a generative pre-trained model. Am I correct now? It is basically pre-trained model. So you make use of that pre-trained model, GPT, and you finally train it to suit to your conditions. Am I clear?
Yes, sir. Yes, sir. Thank you.
Yeah, anyone? Okay, sir. Thank you. Thank you very much for your
Thanks a
insightful
lot.
session on data quality and AI. You're highlighted with great clarity how the foundation of any effective AI system lies in the quality, consistency, and trustworthiness of the data that feeds it. The session was truly enhance our understanding of the critical role of data governance, validations, and ethical consideration in building reliable AI system. On behalf of all the participants, we extend our sincere gratitude to you for sharing your expertise and valuable insights with us today, sir. Thank you. Thank you so much.
Thank you to all
Yeah,
of
thank
you.
you, sir.
I wish
Thank you.
all the best to all of you. For any of the further queries, my email is with you. Please get connected. Thank you.
Thank you, sir. Thank you so much. Yeah, Dr. Deepak Mane, sir. Hello.
Hello, ma'am. Yes,
Yeah,
I am here.
yeah, welcome, sir. Welcome, sir. It is my pleasure to introduce our distinguished next speaker, Dr. Deepak Mane, sir, who is currently serving as a professor and assistant head admin in the Department of Computer Science at Vishwakarma Institute of Technology, Pune. Dr. Mane has more than 20 years of rich teaching experience, and his academic journey reflects a deep communication to the education, research, and institutional development. His research interests span across artificial intelligence, machine learning, data science, and advanced computing, and he has numerous publications to his credit in a reputed journals and conference. His work is widely indexed and recognized with visibility across the platforms like Google Scholar, Scopus, or Cheers likewise. Apart from his academic achievements, Dr. Mane has been actively involved in administrative leadership as the assistant head admin at VIT, contributing significantly to the academic quality and institutional growth. With its blend of academic expertise, research contributions, and administrative insight, Dr. Mane continue to inspire students, colleagues, and researchers alike. So, so I would like to welcome Dr. Mane, sir. Let us extend a warm welcome to Dr. Mane, sir. Yeah,
Yes.
thank you, sir. Over to you, sir.
Okay, thank you, ma'am, for a nice
Welcome,
introduction.
Mani sir.
Yeah, hello, ma'am. Yeah, good evening.
Good evening. Welcome.
Yes. Okay, today's my role is to tell you about the AI in research paper writing, and I hope now you have a knowledge about AI in healthcare, AI in education, AI in social. Okay, so in how we can use the AI in different fields. Now, after getting this knowledge, my role is tell you how we can use the AI to write a paper, or how we can use the AI tools to write a research paper, or how we can use the AI in education. Okay, so let's start with the basic question in all our mind. Okay, when we are starting any project, or when we are starting any trying to give the solution for any problem, or so what is the project, product, and problem? So this is basic question. So I will start with this basic question. In my session, I will try to cover the different concept, like as I will start with the definition of the project, product, and problem. Then we will discuss what are the different important steps to write a survey paper, what are the different important steps to write an implementation paper, and then we will discuss how we can use the different AI tools. Okay, there are different AI tools are available. So how we can use the different AI tools to write a research article. So this is my role. So I divided my session in three parts. One is a survey paper, one is the implementation paper, and third is a AI tools for the paper. So let's start with some basic question in our mind. What is the project, product, and problem? So I will take one example. If in my city, I'm from Pune, and in my Pune, if I saw some problem in around me, and I'm saying the traffic is one problem. Okay, so traffic is one problem, and I'm trying to give the solution for that problem. So what I can do, I can do the different project under that problems, and when I combine the solution of different project, when I combine the different solution of different projects, I can give the solution for a particular problem. So like as I can do the project for the vehicle type classification. I can do the project for vehicle speed classification, detection. I can do the different project for the vehicle color, vehicle logo. So I can do the different project under this problem, traffic intelligence system. So I can give the solution for this problem. So when I'm implementing the different project, and when I combine the different solution for different project, I can give you the solution for the one problem. Another problem, we can say the pollution is a one problem. So which project we can do? So what is, we can give the different solutions, okay, different possible solution to give the solution for the one particular problem, right? So we can put up our idea, we can put up our different possible solution, okay, to tackle that particular problem. This is the problem. What is the project? For when I am saying the vehicle type classification, I want to classify this vehicle in different classes, in different category. In that case, what I need to do, I need to implement, I need to compare my result with the, if any existing approaches are there, existing models are there. What I need to do my result, compare my result with the existing approaches. This is a project. What is, this is the project where I need to implement, I want to demonstrate, I want to compare. And product means what? If I want to convert my project into the product. In commercial, I can add some commercial ideas, I can file the patent, I can publish a patent. Okay, after getting the grant, I can commercialize my product in the market. So this is a conversion of the project into product. So this is a basic terminology. Okay, so what is problem, project, and product? Now when I will start the research project, or when I am trying to write a research article, okay, there are basic steps we should remember, right? Like as a start with the essential question, okay, design a plan, okay, design, create a schedule, okay, and after completing that project, what is my expected outcomes, and how I can compare the my result. Okay, so like as we can say, this is a feasibility, this is a feasibility. For doing anything, I need to, okay, I need to design some steps, and when I follow these steps, then only I can achieve whatever I want. But when I see the different titles in the market, there are different domains are there, right? Like, and someone is saying the data science is important, someone is saying the okay, security is important, someone is saying the animation is important, someone is saying testing is important. So there are different domains in the market. Now which domain I can select? Okay, so if you have a knowledge about the some concept, for example, I know the part of the data analysis, data mining, data analytics. Okay, so I can go with the data science. If I'm interested in some image, I can go with the image processing. If I'm interested in the audio, I can go with the audio. So there are different data available in the market, like as audio data, video data, text data, right? So we can say this is the multimedia data is available. As per your interest, you can select the domain particular. Okay, if you don't know, you can start with the basic. If you are saying I'm interested this in this particular domain, I can search more on that domain, and I can start the studies. But there are different emerging technologies there. Okay, day to day, we know that in computer field, day to day technologies are changing. Before 5-10 years, we are seeing the, yes, definitely big data analysis very challenging task, because before that, image analysis, image processing is a challenging task. Nowadays we are saying this, okay, handling the big data is a challenging task. So there are different domains are there. As per your interest, as per your interest, you can select a particular domain, whatever you want. Okay, now when we decided your interest, and when you are trying to okay, select any project to implement something, so how we can start, and how we can take a first step towards that research project. Okay, so first thing is you need to identify your interest. As I said, okay, first important thing is, as per your interest, you can identify your domain. If you identify your domain, then try to identify the current trends. Like as in market, what we can say, there are a different recent trends of AI, like as a explainable AI, or multimodal AI. So there are different domains, recent trends related to your domain. So you need to find the recent trends. Then if you find the recent trends, you must to review that trends. What are the different existing work in my that particular domain? Then when I select this particular problem, how I can give the solution for particular one problem, like as a real world problem, is there any related problem is there, and I'm giving the solution for that, like as a pollution, as I said. So I am giving the solution for particular that pollution problem, right, in my city, right? So based on that, when I'm selecting the title, I need to clear the objective. Okay, many times researchers don't know what they can do. Okay, many times they are implementing many things, but they don't know what was my scope. So before implementing anything, you need to decide your scope. Okay, and based on the scope, you need to put the different constraints and okay, different when I implement, what are the different evaluation parameter I can consider. So these things you should remember when you are starting any research project. Now important thing is, when I'm trying to implement any things, important thing is I need a data. So everyone, I hope you familiar with the terminology of AI and what is the objective of AI. Okay, machine can think like as a human, machine can take a decision like as a human. Okay, so machine can behave like as a human. This is objective of AI, and to achieve this objective, okay, we are using the different algorithms, like as we know that machine learning is a subset of AI and deep learning is a subset of machine learning, right? But for doing anything, when we are talking about the artificial intelligence, machine learning, deep learning, data science, everywhere we require a data. Without data, we can't do anything. Without data, I can't process. Okay, so what we can do, we can search the data on the net. We can search if data is not available, and I know the some knowledge about that particular data, and I'm taking the some guidelines from the experts, and based on that guidelines, if I'm preparing my own data set, right? But what is bottom of line? We required a data. Without data set, we can't implement, and we can't say my idea is good for particular problem. So we require the data. So where data is available, so normally we are using the UCI site, okay, website, and by using that UCI, we can see the different data sets are available on that UCI sites. Also we can see the Kaggle website. On Kaggle website, there are project competitions are going on, and they already they have their own standard data set, authenticated data sets are there. You can use that data set and you can start. As well as there are many online sites are there, like as if hackathon is going on, and they are putting their own data set. So many online competitions are also there. You can take that data set and you can start. ImageNet is related to the image data set, and this is world's largest data set for the image. Okay, so if you want, there are many pre-trained models are available on the ImageNet. You can use that, and there are different links are available. Like as some of them I uh, 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 kept in my slide, so you can see MNIST or COCO, IMDb. So there are many data sets are there. So you can go with these sites, and you can use that data set. Nowadays, you can also see the some GitHub data set. GitHub, many researchers are doing their research, and they put all the data set or their all the model on the GitHub, and you can start with this data set, and for your any titles, or for your interested domain. Now when we start, we know that we are using the DLC model. Okay, so you must do the analysis for requirement, then requirement analysis, then implementation, then testing, and then deployment. So these are the basic steps of any software development, and by using that different steps, I can start my implementation. So if I decide my domain, so where I can see the similar titles, like as if I am doing my PhD, I am a researcher, and I want to see the existing thesis on my particular title. Okay, So how I can search? I can visit the Shodh Ganga website, and I can search the similar thesis on that Shodh Ganga website, and I can refer this thesis, and based on that existing thesis I can start my study. So we required some existing titles, we required some existing work, we required some guidelines to start my research. That is very important thing. So how I which websites I can use them. I just put the some of them. It is not only all site, but we can consider as some sites are there, like as the hackathon is there. Every year India is conducting the hackathons, and they put the titles under the different particular domain. Normally which titles are there? Normally the titles are related to the agriculture, related to the medical sector, related to the smart city, or related to the industry, or nowadays we can say the sustainability related titles are related to the sustainability. So you can see the different titles under the different domain. These are the some domains on slide you can see. So in that you can see the titles in the hackathon, and you can start to thinking on you were interested domain. Okay, another website I can say, the different industries are conducting every year the hackathon type of competition. Veritas is conducting different illuminate competition, or KPIT is conducting the sparkle competition. So you can see the titles on the different titles, okay, in different domains, not only computer, in different, in mechanical, in electronics, there are different titles are there. You can check, and you can start the study of your interested domain. So this is another site where you can see the some titles of research titles. Nowadays, okay, uh, the city is also proposing their problems. They are putting their problems on their website, like as a Pune. I am a part of the PCMC, so I can show you their website. They are putting their problem on the websites, and we can also check what is the current problem in my city, and how I can help to give the solution for that particular problem, right? So smart city is also giving the some problem. Okay, government manthan is also competition is there. By using you can also visit that competition, and you can see the titles. Another important website is the Kaggle, as I say told you about the Kaggle. Many competitions are going on. You can see, as you can search as per your interest, as per your domain, and you can see their requirement, and you can start the implementation. Okay, so this is another site, is the Kaggle, right? So is it, this is the idea. Okay, I will also tell you about how we AI tools is useful uh, to select a particular title for my research. Okay, this is some websites are available. These are the some hints are available. So I will share, I am sharing, but how AI tool is also useful to decide my title. I will share, I will also demonstrate that one also. Don't worry about that. Okay, so next part is the paper selection. Now when I decide that this is my problem, or this is my domain, like as if I decided I want to do the project in the some crop disease detection, for example. So in crop disease detection, so this is the part of the agriculture. And what are the problem statements are available in the hackathon? What are the problems are available in different government competition? When when I gone through these titles, I decided I want to do this particular project, okay, or research project, I can say. So how I can collect the paper? How I can collect the paper? As we discussed, there are different size to give the data set, like as the GetUp is there, Kaggle is there, UCI is there. I can use that site for my data set. But when I decide my topic, what are the different websites are available, okay, for the paper selection? Like as normally, okay, we are taking the papers of the standard journals, like the IEEE, transaction, or like as we are saying the SCI journals or Scopus journal, or we can say the SCI Q1 journal or Scopus Q1 journals. Okay, so different websites are there. From that website you can collect your papers, like as IEEE Explorer is there. We can search the papers on that site. ACM is there, PubMed is there, Science Direct is there, Springer is there, Google Scholar is there. You can search the titles on Google Scholar. ResearchGate is there. Okay, so there are also preprints are also available on archive. Nowadays we can see the some if some researcher are not publishing their papers, but they can put their papers on that archive also, because archive is also giving the DOI for that particular paper. This is also considering as research. So you can select the papers from these different websites. From this different website, this is the, these are the some guidelines to you how you can download the data set from which data which website, and also if you want to collect the papers, from which papers you can uh, collect the papers. Now when you decide the domain, when you decide the problem statement, and when you collecting the papers, now you have a papers. Now if I want to start to write a survey paper, try to understand. Okay, this is the first step when we are doing any research or when we are doing any project. Okay, we need to understand the existing work of related particular domain, and based on your observation, if you are writing the paper, that is also very important. Okay, what I seen in a research domain. Okay, if you are writing the survey paper, you will get more citation than the implementation paper. I'm not comparing the implementation and survey, but try to understand survey paper is also equivalent to the implementation paper. If someone want to do the project in particular domain, and your paper is giving the particular research direction for that researcher, okay, then that is also important thing. So when we are writing the survey paper, you should remember the some important points. Which points I should include? Important points is what? Okay, if I am particularly selecting a particular topic, and when I put the survey of this paper in particular paper, so what is my observation on that paper? Like as I am referring the 100 papers, and I put the observation okay, uh, observation on that 100 papers in a table, and based on that table I am saying something, what I observe. Okay, so that is very important. That is a part of the critical analysis. So I take that point. The critical analysis is very important. Whatever the paper I am using in my paper, okay, to write a survey paper, I must give the site for that papers. Also I must draw my own figure. This is a survey paper, so don't copy the figure from the another paper. Whatever your observation, based on that observation you can draw. I will show you my one paper, how I have written my papers, and how many citation I got. Okay, so critical analysis and figures is very important thing. And try to understand, for a survey paper, don't copy text as it is from the other paper. Okay, try to avoid the plagiarism. Nowadays, you know that AI content and plagiarism these are the major issues to rejecting the papers. So don't copy. When you read what is your understanding on that paper, you can write in your own words. Okay, and you must follow the proper formatting for the particular journals, right? So like as I will show you my one paper, like as this is my own paper. Yeah, so is it visible?
Yes, sir. It's visible, sir.
Okay, okay. So I have written the one paper in 22. Okay, the title is the survey on the anomaly detection. Okay, so this is a comprehensive survey. So you can see here in my abstract, you must follow the standard guidelines. You can see I collected the some papers in between particular years 15 to 22, and near about I use 101 research articles to write this paper. When I read this paper, I observe 30 plus machine learning models are used for this particular anomaly detection. And for this anomaly detection, there are almost 55 data sets are used by the researcher. Okay. So this is abstract. So when anyone is reading your paper, definitely they will attracted towards your papers, and they can start with reading your papers, like as application of anomaly detection. These are the different applications in that anomaly uh, is happening. And I'm putting the introduction. Then when I start the literature survey, I must put the diagram of flow of my diagram, like as what is the methodology used for the survey. So you can see the diagram, how what is the organization of my paper in my literature survey, what are the steps I am following. So these are the figure for that. Then after in literature survey, I am putting the what is my selection criteria for my the survey paper, and then what is the objectives. Okay, next is what is the objective of my paper. And then observation tables don't copy as it is, so you can take important parts and you can put the important thing, like as you can see here, the year is there, which method is there, and which data set is used, which performance matrix is used, and what is the value for that. So when you put the result in the tables, this is the first part of the survey. Okay, you must put your observation in that table. But after that, we can say the this is the one my observation. Okay, the different data set used for my anomaly detection, and which are the latest technique, like as a support vector machine neural networks are used. So I can put this their advantage or disadvantage, strength and weakness of the each machine learning methods used for the anomaly detection. So I can put the strength and weakness, and based on that, again I'm based on the observation, I can put the another diagram. Okay, different application of the anomaly detection from the research. Okay, so from the 101 research paper I am drawing. An important thing is observation on your literature survey. So what is the important thing? When I put the results in the table, okay, what you observe? Outcome of the survey. Which outcome? When I read my 101 papers, what I observe. So machine learning has a supervised, unsupervised, semi-supervised. So I drawn first diagram. Next diagram I drawn. Okay, so these are the different techniques are used for the anomaly detection, and from that figure itself I can say which method is giving the highest results for that particular title. So I can put the machine learning technique in the tree, and uh, after the limitations of the papers and the conclusion, and then I put the research papers references in particular sequence. Why I am showing this? Because based on that, if you follow some proper guidelines, you can see, okay, in 2 years I got 44 citations. I got a 44 citation. So I am giving the equal weightage for the survey paper also. When you are doing any research, what is important thing? Important thing is, first step is how you are understanding existing research on your title. In how now, if someone is want to do the research in anomaly detection, so my paper is definitely give the right direction to that researcher to do the research in that particular domain. Okay, so this is a research paper. This is the research paper. So when I am following the proper steps, whatever we have discussed, critical analysis, your own figures, and avoid the plagiarism and the proper standard formatting of that journal. This is the important steps to write a survey paper. These are the same explanation is there. So I have some less time I need to complete. Okay, before 5. So just I ignoring this part, but I hope you understand the different important steps in the survey paper. Next important part of your research is, if you understood what was my okay, what is my title, what was the existing work for my title, and what are the limitations of the existing approaches, and based on that I'm trying to propose my own architecture, proposing my own model, how I can give you the solution for these challenges, how I can overcome the existing limitations of this particular title. Okay, so implementation paper is also important. In implementation paper, what are the important section, like as in survey paper what we discuss, important sections are critical analysis. How you put your contents in the table, how you put your contents in different graphs, and how you analyze different graphs. Okay, and based on this comparison you are giving the proper guidelines to any researcher. This is the important part of the survey paper. Similarly, in implementation paper, what is your proposed architecture, what is the novelty of your proposed architecture, how you explain your novel architecture, and how you compare your implementation result with the existing approaches. This is the important parts in the implementation paper. But remaining things are also important, like as what is the methodology, architecture, implementation steps, pseudo code, implementation, experimental setup, result evaluation, and discussion and contribution, conclusion, some future work is there. So you need to consider this standard part, you need to consider this standard part. 1 minute. Okay, so important things are the methods, your results, and how you compare your result with the existing approaches. Okay, this is the important thing. So you must follow the standard guidelines, and I'm just following the standard guidelines. And okay, believe me, in last 2-3 years, I publish more than 50 papers in a Scopus. Okay, just what I am doing, I am following the standard guidelines. Important thing, what in implementation paper, I am a reviewer for the different journals, like as I'm a reviewer for the IEEE access. Okay, when I'm reading the any papers, what is the interested section? Interested section is, what is the proposed architecture, what is the novelty, what is the novelty, what is the novelty of that proposed architecture. Okay, novelty of that proposed architecture, right? And how you put the results, how you explain your proposed architecture in some mathematical terms, and how you compare your result with the existing approaches, right? Like as this is the same, another one paper is there, another paper is there, I will show you. Just I follow the guidelines. Now in our teaching community or any research, okay, we are trying to say no, it is very difficult to publish a paper in some journals. But if we are following the standard guidelines, definitely we can publish a paper. Huh? So what is the standard guidelines, like as a okay, in abstract, what we are expecting about the title, about the titles. Okay, what you are proposing in this paper, and what is the novelty of your proposed methods, and how you compare your performance, okay, on which data set, and what is its data, okay, what's its performance. Okay, so this is a common guidelines to write a abstract. Okay, in introduction, at the end of the introduction, you must put the objectives, and in related work, at last part is the observation of the literature survey. But in support, in system architecture, first paragraph is what are the existing challenges and what you are proposing, and how your model is giving, okay, okay, giving the better performance. Okay, and on what basis. So this is the novelty. Explain the novelty of proposed architecture and how your proposed architecture is okay, tackle the or giving the solution for the existing challenges. After that, you can explain the model of this proposed architecture model wise, and if possible you can put the architecture like as there are different ways to put the architecture algorithm, like as you can put the pseudocode, or you can put the some different steps like as a forward step of your proposed architecture. So there are, how you explain your model is also important. Now I published this paper in Q3, Scopus Q3, but when I observe the expectation is how you are explaining your proposed architecture in mathematical terms. Based on that, I publish a paper in IEEE Access. In last year itself, I published a paper in IEEE Access where I explain all my models in mathematical terms only. So this is also important. So you must aware about this okay, techniques. So how I can put the algorithms and how I explain my proposed architecture. An important part is experiment results. So how you implemented, and how, which graphs you are using, which graphs are you are using. Normally you can use the confusion matrix, you can use the some graphs for the loss versus, okay, training, and you can put the result in the classification report. And important thing is how you compare your result with the existing approach. So you in on screen you can see, so this is my tables, and for its particular title, whatever the title is there, like the retinopathy. So different researchers are trying to give the accuracy on this particular data set, but my proposed model is giving the better accuracy than the existing models. So based on that, based on this, this is the simple trick. So you can publish your papers, you can publish the papers, and this is these are the important part, different parts of the implementation. What I told, first is architecture or method, second is how you explain your novel architecture, third how you present the results in different formats, like as you can put the result in table, you can show your result in a graph. Okay, and fourth important thing is how you compare your result with the existing operation. If you follow, definitely, okay, you can publish a paper in any journals. I publish a paper in paid journal. I publish a paper in non-paid journals. I publish a paper in UGC journals, as well as, okay, some papers never I got indexing in the Scopus. Okay, so I have some experience. Based on that experience, I am saying, okay, the that experts what they are expecting. What we need to find out the particular journals. Like as if I am doing the project under the agriculture or in medical sector, so what are the related good journals relate in my that domain? If you know that, definitely you can publish a paper. They are expecting uh, the novelty in your paper. So these are the same thing I am explaining in different sections. So you need to put the results in different graphs, compare your result with the existing work, and you must use the guidelines of their template. How we can use their template. So common thing is to write implementation steps are, you should remember is this: abstract, introduction, related work, propose architecture, experiment result, conclusion, and references. These are the expected section in any implementation paper. You can add in one additional section, that is the discussion. In after experiment result, when you compare your result with the existing approaches, you can add the discussion. Okay, when I publish a paper in IEEE Access, okay, I observe that, okay, discussion is also important. Okay, so you can put the summary as a part of the discussion. Like as I put the result in the tables, some points are giving the good results, some points are not giving the results. So why this particular point is giving the good results, why this particular point is not giving the results, you must discuss in that discussion. Okay, based on that discussion, okay, another researcher can use your paper, read your papers, and they can continue their research. Okay, so this is the steps. These are the steps for survey paper. These are the survey papers as well as the implementation paper. Okay, so what we started, okay, what we started, okay, how we started. I started with, first I need to find out my interested domain. Many times, okay, uh, we are wasting our time to find out the interested domain. Okay, so what you can do, you can find the interested domain, then you can search different papers or existing work on that title. After reading some papers, you need to finalize some papers. Like as when I start my reading particular problem, like as for example, the again is the okay, detecting the crop disease. Okay, crop disease. So when I saw the 100 papers are there, initially I found 100 papers. When I read 100 papers, I shortlisted 50 papers. 50 papers are related to my titles. When I carefully read again these 50 papers, I okay, I can see these are the 20 or 10 papers are very important, where I can see these are the some limitations are there. If I am giving the solution for that limitation, definitely I will give you the better performance than the existing. And for the 10 paper, when I decided these are the 1 2 papers are there, when I want to start my implementation, I considering these are the base paper. This is the base paper. One paper we can say this is my base paper. Now I am trying to implement my research idea with this base paper. With this base paper. So you can start with this base paper. This whole learning is based on the try and error. We know that the machine learning, okay, we know that the definition of the machine learning in Tom Michel book itself, they have mentioned all learning is based on the try and error. All learning is based on the try and error. So when we are trying to give the solution for particular problem, we need to train the model again and again, and with the different approaches, definitely, okay, you can give the, okay, good results, and you can compare your results with the existing approaches, and you can publish a paper in good journals. Okay, so when I am talking about the journal, good journal, many times what is happening, okay, my colleague is asking about me, sir, tell me or tell us the good journal, tell us the good conference where we should publish a paper. Okay, I am asking, there are many conferences are there. They are asking about the what are the different conferences. Okay, if I am saying if I am searching on the Google, like as top top international conference in computer science engineering. Okay, so it is giving the link, and if I open that link, open a link, you can see the different titles, like as where I can publish a paper. I am not blaming any conference, but I am showing you the some good top conferences in our computer science. So you can see that this site, is it visible? Core computer science references ranking website. Is it visible?
Yes, sir, it is visible,
No.
sir. Yes, it is core computer science conference ranking. It's
Correct,
visible, sir.
correct.
Yes, now
So
it is visible.
huh. So try to understand now. When I want to publish a paper, okay, so you must try to publish a paper in that core conferences. I am saying the core conferences. Number of conferences are going on in India also. If I count the conferences, more than 100 conferences are there. Okay, but you must know this, what are the different, like as I want to publish a paper in my machine learning domain, I don't know. So title, you can see here 6 conferences are there, like as this international conference on machine learning, its ranking is A plus. ICML, this is the topmost conferences, conference in my machine learning domain. Another conference is British Machine Vision Conference, is grade is 1A. Okay. Another is European Conference on Machine Learning, A grade. Also, I can see the some titles under the ranking B. So there are many conferences under the machine learning. If I want to publish a paper in data mining, okay, so you can see that IEEE International Conference on Data Mining, its grade is A plus. If I am doing the neural networks, so I can say neural IEEE International Conference on Neural Networks. So 10 conferences are there. International Joint Conference on Neural Networks, it is a conference. So there are, you can see here A plus, A, then B, then C. Many conferences are there. If you are researcher, okay, then try to publish a paper in core conferences. Okay, there are many conferences are there, and for your hint, there is no core conferences is going on in our India. Try to understand. So you must think, and you must find the core conferences, and then you can publish a paper. Okay, then you can publish a paper. This is also very important. Sometimes researchers don't know how they can search the Q1 journal, how they can search, okay, how they can search the Q1 journal, how they can search the Q2 journals. If I am opening the one Scopus page, okay, there are different sites are there, like as one Scopus is there, right, Web of Science ka alag alag, Clarivate or another site is there. Okay, I can open, and I can, what I can do, I can search the journal, like as I can put the search, and in search, uh, from the sources I can give you the title option, are there titles, and the quartile select the quartile, like as I am putting, I want to search the IEEE access. Okay, IEEE access, right? And there is one, if I select Q1 quartile and I search, conference is there. If I say Q2, I select the Q2 and title is access. No conference is there. Means what? When I select the Q1, it is showing. Okay, when I select the Q2, it is not showing, means it is the Q1. This is a shortcut trick. Sometimes what we are doing, we are searching the same site on the Skyhub. Small confusion in Sky, this Skyhub. Okay, SciMango is there. Sometimes it is showing it is Q1, but sometimes it is showing like it is taking a last year data. It is taking a last year data. So don't believe on this site directly. You can search on the different sites. Similarly, you can search on the Web of Science Clarivate. So one site is there. uh, Similarly you can search. Okay, so in this way you can search the which journal is Q1, which journal is Q2, which journal is Q3 and Q4. Accordingly you can publish a paper. There are different queries related to, okay, indexing. That is not our part, but I hope you understand, or you understood the different important parts of the survey paper as well as the implementation paper. Now next my last part of my session is how AI tool. Now we have discussed the different steps. We have discussed the okay, how we can take the data set, and how from which site we can take a data set, and from which site we can see the different titles for the particular domain. Okay, but how AI tool is useful for the researcher? How AI tool is useful for the researcher? I hope everyone is familiar with the chat gpt. Chat gpt is the best example. Okay, chat gpt is giving the some use, okay, some guidelines, some suggestion, some information to you to do your project. Google search engine is also giving some information to you, right? This is the, okay, this is the automation, something automation is there. But when we are saying the intelligence, AI, artificial intelligence, yes, definitely at chat gpt at backend, inference engine is there, transformer concepts are there. They are creating the knowledge graphs, and based on the knowledge graph they are extracting the new knowledge from the existing knowledge. The intelligence is there. Chat gpt is the best example, is giving the information to us. But what is the problem with that chat gpt? Evidence is not there. Proper evidence is not there. Like as if I want to search the title, okay, I want to search the title, I want to the same, a simple example, the same example, I want to do the project in crop leaf disease detection. Okay, and I want to see the titles. Can I do the project in that domain, or can I search the some papers in that domain? So I required evidence. My guide is expecting this is the information, this is the evidence for that information. So everyone want the evidence. Without proof I can't give you the guarantee about that particular data. Chat gpt is giving the data, but sometimes it is not giving the proper evidence. Proper evidence. So to search your idea, to search your idea with evidence, you can use the AI tools. Many AI tools are available in the market. In my presentation, I will try to cover some, at least 5 AI tools for the researcher. Like as Consensus is one's website where, okay, I directly open that website. One website, by using that, by this is the site, so I directly open that site. Okay, so I can put the idea, and based on that I can try to search the idea with evidence. Like as I want to do the project deep learning for crop disease detection. Okay, so if I want to search some ideas, so it is giving some papers with evidence. With evidence. Now you can see here deep learning for crop disease detection, and they are also putting the some text information with evidence. So this is a part of this, and you can see that this is the paper for this. This is the first number, this is a 4 number, this is a 6 number. When I click one and detail, I can see the its details. I can see the details. At right hand side, I can see its details. Right. So this is my idea, and this is the evidence for that idea. Okay, I am doing what I want to do. I want to do the project in crop disease detection. I'm searching the idea with the evidence. So you can see here, it is giving the text, and it is giving the evidence of that proof. So I can search that. Also I can put the different filters, uh, uh, different filters for that. Like it is giving this whatever the, okay, chat gpt is giving the same, but it is not giving the exact proof. Here it is giving the proof, so it is helpful for me. Don't copy as it is in your paper or anywhere, try to understand and rewrite. Okay, so it is part, it may be in AI content. So you can see the papers are there. Also you can see the its citation. Okay, so first paper has, this first paper has a 200 citation, like as a 22 papers, okay, 22 years paper, 200 citations. This paper has a 3000 citation, but paper is from 16. So you can see the different. Also you can put the filters, you can put the filters like as deep. I can put the filters like as filter is, I want a paper from Q1 only. So Q1, Q2, Q3, Q4. I want to show my to my guide. So I am saying, okay, you must apply the filter like as you must take the Q1 papers only. Deep learning, same query for crop disease detection. Okay, मैं copy करके रखता हूँ. Okay, and I put, it is giving now the information with Q1 papers only. So you can see here, it is giving the evidence, it is giving the evidence from the Q1 only. So you can see it is giving the summary, like as the current capabilities, models and challenges, effectiveness of the applications, and some key observation, what are the current models are there. It is giving the summary. Also it is giving the link. If you put there, you can see this directly cited. Okay, that paper is there. So you can, if I want to put, I can click here and I go with that PDF. Sometimes PDF is not available. Try to understand. If PDF is open access, then okay, it is giving the PDF. Else you need to access that paper from the different website, other website. Like as if you have a premium login, then definitely you can access. Right. So these are the first hint. What you want to search your idea with what? With evidence. If I want to see details, I can click here and I can see the papers. I can see the papers and I can refer these papers. Right. So this is the first thing. This is the first thing. What I want to search my idea. I want to search my idea. Another option, AI tools to search your ideas with the evidence. We are talking about the evidence. Another site is Kineas is another site where you can upload. If you have a paper and you want a related paper, or if you want to see the some titles, like as I copied the titles and again I want to search, okay, the ideas related to deep learning for the crop disease detection. So I can see the similar results are there, but the evidence is there. Important thing is what? These are the AI tools are available on the internet. Just we need to log in. Okay, I already log in through my mail ID. So it is giving the result like as deep learning methods for detecting crop or plant disease. So it is giving the summary, and left hand side and right hand side is also giving the again the some papers are there. Like as based on that, you can think on your title. You can think on your title. I'm giving the particular title. You can put anything. Okay, so it is giving the reference, and just you need to click that reference and you can okay, open that paper and you can read. But what is the important thing? It is giving the idea about how I can select the title, how I can select the titles. Third important AI tools is available on the internet. Okay, there are many. There are many. Uh, uh, this is the some I am showing. Like as third is the SCI space AI tools is available. Okay, here you can upload your PDF. Here you can type your anything. But what we need, I need to prepare a chart. Now, if I decide my title, okay, so important thing is what? Literature survey. What we have discussed, the survey paper, right? Similarly, I want to see the table. How I can put the table in my survey paper? How I can put the table in my survey paper. Like as a, similarly, I upload the my one paper is there, or I want to click the literature survey, and I can ask the same thing, uh, give the results for again deep learning crop disease detection. So what sometimes it is asking about the premium, but I'm using the free version. So this has some limitation. So it is giving the answer as well as it is giving the answer as well as with the reference, with the yes, anyone has any doubts? Hello, participant should mute your mic.
Bhandari sir, please mute everybody's mic except speaker.
Yes, madam.
Please mute everybody's mic except speaker.
Done, madam.
Okay, so another is essay space, where you can upload the papers and ask anything, like as a chat with PDF. You can ask anything related with that papers. You can ask which method is used, what is the limitation, what are the result is there, what is the future direction, as well as related review, what are the related work is there, and how I can see the like as a related review. I can click there, I can put the results, and I can refer these results for my literature review. This is the third AI tools I can use for my research article. Another tool, another tool is available on net, is related to the insightful. Okay, so insightful is the after related work. This is also useful for the related work. Again, I can insert the same query, deep learning for the crop disease detection. You can see that it is giving the papers, but it's it has a wonderful characteristics, or we can feature, like as a we can see the graph. Okay, this is my paper, and if I want to see the graph of particular paper, so these are the different papers available related to the crop disease detection, and what is the relation between that. This paper is site there, and at back end he is creating the graph. Okay, sometimes you can think on, yes, definitely this particular data set is very important, and I can also put the different constraints, like as I can insert the filter different constraint, like as I want to create a graph in between this particular year to this particular year. So I can use this insightful again for what? Again for what? Literature survey. First two site, which consensus and the Kenius site, I told you about how you can search your title. Next two titles website, like as a SCI space and Insightful, is useful for the literature survey. Literature survey. Next important thing is what? System architecture. Next important thing is what? System architecture. Like as after my title, after my by using these two sites, I can decide the titles. Okay, consensus and Kenius, I decide the titles. By using for the literature survey, I can use the SCI space, and I can use the Insightful for my literature survey. In Insightful also, you can put the year, you can put the different filters, like as I want to search only the paper in between 2015 to 22 or 25, so you can use this. After that, you must put the results in some we already discussed, okay, related to the implementation. Method is there. In method, you must draw the diagram. If you want to draw a diagram, there are different AI tools available on the internet, like as graph.io, graph.io. You can use that graph.io for drawing your diagram. So this is the drag and drop website. So you can use the existing template, or you can draw your own diagram by using this graph.io. Okay, so title over, literature survey over, implementation over. Okay, next part is write the pseudocode. You must put the pseudocode in particular format. Okay, particular format. The standard format is what is the input, what is the output, and pseudocode for your titles. Next important thing is the result. Result you can put the result in tables, in different graphs, and you must compare. Important thing is you must compare your result with the existing approaches, and give the proper justification why your model is giving the better performance than the existing. That is important thing. Okay, now if I over the introduction, so title, literature survey, system architecture, methodology, and result. Some sites are useful for giving the abstract. Okay, some sites are giving the title for your results, like as I already open here. So this is a rightful is a one AI tool or one website is there. At backend the AI is used. So when I put them some abstract here, okay, if I put the some abstract, for example, this paper we already discussed, so I'm uh, taking this abstract, and I'm asking about the give me the title for this abstract. So what it is suggesting me the some titles, and sometimes it is not under the plagiarism, because I am giving my own data, and based on that data it is giving the title. Like as you can see here, he is generating the title for my abstract. Okay, CCNN deep learning approach for diabetes retinopathy detection, as well as many AI tools. Or I hope you familiar with the Springer Suggester or Elsewhere Finder. So these two another websites are useful to suggest the titles or particular for abstract which journals are suitable. But particular here what it is, if I'm putting this all the contents of my paper, it is generating the abstract. If I put giving the abstract, it is giving the title for my paper. So this is the rightful is another AI tool is there, which we can use to generate the title, which we can use for generate the abstract, which we can use for generate the abstract. So after generating the abstract, important thing is the references. You must insert the references as per the standard guidelines. As a summary, what we can say, there are different tools, AI tools for research paper writing. Okay, like as we already familiar with that. Sometimes if I want to use the proper grammar, insert the proper grammar, I am using the Grammarly. If my paper is in plagiarism, remove the plagiarism. For paraphrasing, I am using the Quillbot. To check the plagiarism, I am using the Turnitin. To give the proper visibility, I am putting my research on the Google Scholar, ResearchGate, Scopus, with one ID, right? So these are the different tools are there for writing the research paper, like as AI. Okay, if I am saying the assisted research and literature survey, best example is ChatGPT. You must remember, huh? But when what we have discussed, what is the important thing in ChatGPT and this particular AI tools? This is in ChatGPT. In ChatGPT, there is no proper evidence is there. There is no proper evidence is there. But in this particular site, like as which site, Consensus, Kenius, these are the some site which are giving the proper evidence for that. Uh, Academic writing assistant, like as I want to write something, so we know that Grammarly is helpful to remove the grammar. Quillbot we are using to rephrasing the grammar. Content generation and structuring. So already we have discussed the some sites, Kenius, Conscious, SciSpace. By using that text, we must read that text and write in your word one. Similarly, you can use the chat GPT, understand, and based on that understanding, you must write the text in your in your format, or in your whatever you understood from that text. Okay, you can write in your own words. next is the citation management and formatting. There are different tools are there. Mendeley is one there. We can use the Mendeley, and we can use the give the proper citation for the different papers are there to remove the plagiarism, to detect the plagiarism. Turnitin is there, Quillbot is there. We can use these tools. Journal selection and submission support already we discussed. Springer and elsewhere they are giving the some features, like as you can put the abstract and you can search the papers, okay, where you can publish a paper. Also improving the paper visibility and citations, like as I want to I want to improving the paper visibility, like as I can put the paper in Google Scholar, as already I shown you my Google Scholar, Scopus, or Seed, ResearchGate, Academia. These are the different websites where we can put our papers, and automatically they are extracting, but sometimes we can also manually we can add, and we can improve the citations. As a summary, what we need to think about AI technology. These are the new things in the market, and you must aware about this technology. Okay, so day to day they are changing, so you must aware about the digital technology. Then you must adopt this technology. Okay, learn to adjust to new way of the living and working, and with the digital tools and literacy. So you must adopt this new technology, acquire, learn new digital technology skill, then only you can say I have a knowledge about that digital technology. If I don't know the how I can use the chat GPT, there is no use of that website or whatever we have discussed, the different AI tools. If I don't know, then there is no meaning. So you must acquire the new skill. And last one thing is that you can achieve uh, by being aware, adapting, and acquiring the skills, you can achieve success in health, wealth, and work-life balance. So important thing is the achieve. So you must, yeah, remember this: aware, adopt, acquire, and achieve. With this line, I stop here. If you have any questions or any doubts, now next some time for you, you can unmute and you can ask. Still, if you have any doubts, you can reach me through my email or mobile number. You can call me, you can ask your queries. So with this word I stop here. If you have any doubts, you can ask.
So I invite all the participants to interact with Dr. Mane sir. If you have any question, you can feel free to ask. Sir,
Yes, ma'am.
yes. Sir, I have one question. So if wait, suppose in the in the research paper, suppose how to write the keywords, how to select the keywords, selection of keywords and title in for increasing the citations, and what guidelines should we follow for the same?
Okay. So yes, very good question is there. Title and keywords is very important. As we discussed, to rightfully the one side for giving the titles, but try to understand when we are selecting the keywords. Keywords are very important. Normally, people are searching a paper through the keywords, like as deep learning is a one keyword, like as a pattern classification is the keywords, like as important algorithm name is a keywords, right? So you, when you are doing any implementation, okay, you know that okay, which is the major concept in my paper, and you can select this particular concept as a keyword, like as I'm as I search deep learning for crop disease detection, so I can say the deep learning is a keyword one is there, and for if I'm using the applying one particular algorithm, convolutional neural network. So I can also think like as a convolutional neural network is also one keywords. But plant leaf disease detection parent domain is a pattern classification. So I can think, yes, pattern classification may be the part of the keyword. So according to this, you can think and you can consider the keywords. Don't put the simple words. Normally these are the keywords based on the some your observation. Is it clear, ma'am?
Uh, yes, sir. Yes, sir.
Okay.
Yeah. Yeah. Any question from participant? Please unmute
Hello,
yourself
sir.
and ask. Yes.
Hello. Yes. Good
Yes,
evening,
ma'am.
sir.
Yes. Hmm.
Yes.
Good
Good
evening,
evening,
ma'am.
sir. Thank you for the wonderful session. It was really insightful. However, when I had some of the experiences when some AI tools were used for specifically for literature review. See, there are lots of students now when we guide them, and they are not interested in going through the hard way or the traditional way. So they take support of AI tools, and most importantly, for the literature review when they do. So what I have observed is tools like ChatGPT, which is most popular, Gemini, and stuff like that. So these tools do not give a proper literature review. That is one of my observations. And what I have found is, which is most threatening, is it gives some of the papers which actually does not exist.
Hmm.
I mean, there are many papers. See, we are blindly trusting the artificial intelligence tools, and we are promoting that one may use. However, for us it is okay, but for the students and for people who are not aware, the it is not guiding properly. That was my observation. I was stunned when I saw that where is this paper, the conference or the
Hmm.
publication they claim it is purely imaginary, and ChatGPT can use any kind of imagination. That is what I have observed. So,
Yes, ma'am.
yeah, so I want certain AI tools that you have shared many. However, out of them, I would like you to just tell us so that we can tell the students as well that at least you refer these
Correct.
tools, AI tools. Yeah, some
This.
one or two, the niche ones. Yeah,
Yeah.
thank you.
So, ma'am, so I have not shared the chat GPT in my whole session because this is the main
Right.
reason, because it is not giving
Yes,
the
right.
exact evidence. So
Yes.
you can tell us. I have mentioned the two tools for the literature survey. One is a
Mm-hmm.
SCI space and another is a
Yes.
insightful. So you can
Hmm.
tell your students you can use these two website or these tools, and based on that you can do the survey. Because in size space, okay, it is also giving the chart like as a what is the method, what is the limitation, what is the technology, and what is the accuracy. So it is giving the
Hmm.
table as it is, but that text has some evidence. So you can share these
Hmm.
links
Hmm.
to
Yes.
your students. There are many, but these are the very user friendly
These are
websites,
the-
ma'am. You can
Yeah.
share this to your students.
Okay. Thank you. Thank you so much. Thank you, sir.
Okay, thank you, ma'am.
Yeah. Anybody? Yeah. So we move for conclusion. So on behalf of all participants, I sincerely thanks Dr. Deepak Mani sir. He has systematically explained the importance of quality data set, standard research repositories, and selection of reputed journals, to also highlighted effective strategies to improve research visibility and the increased citations through appropriate keywords, collaboration, and the different scholar platforms. So we are grateful for this valuable guidance from you, sir, which
Thank
will
you.
undoubtedly strengthen our research practice and academic contributions. Thank you. Thank you so much, sir, for your
Thank you.
valuable time.
Thank you, ma'am. Thank you, Archana ma'am, for inviting me. and giving me the opportunity to share my experience to all researchers or
Yeah,
participants.
it's
Thank
our
you, ma'am.
pleasure, sir. Thank you.
Thank you.
Yeah,
Shall I
thank you
leave,
so
ma'am,
much.
now?
Yes, yes, sir. Thank you.
Okay, okay, thank you.
Now I'll hand over the mic to Professor Titre, sir, to introduce our next speaker, Mukesh Jain, sir. Yeah, Titre, sir, are you there? Wait, next session will be start shortly.
Hello, am I audible?
Yes, sir. Yes, sir. Titre, sir.
Oh, sorry. Give me 1 minute, madam.
Yes.
Mukesh sir, you're there. Mukesh sir, am I audible, sir?
Yes, sir, you are
Happy ma'am.
audible.
Yes, you are audible, sir. But I think
Mukesh sir,
Mukesh sir is not there in the meeting.
I'll call her. Give me a minute, please. मैं कॉल करता हूँ 1 मिनट सर ज्वाइन हो रहे हैं प्लीज थैंक्स मैंने व्हाट्सएप किया ना वो मेरे 97 के नंबर से Sir, good evening. Audible?
Hey, good evening, Dideji. How are you?
I'm fine, sir. How are you?
I'm doing good, thank you.
Thank you so much for your time and the energy, right? So, Kapil ma'am, shall I start?
Yes, sir.
Okay. Shall I start, Mukesh ji?
Yeah, please go ahead.
Okay, thank you. Thank you. So, good evening. I am very excited to introduce to one of our eminent and distinguished alumnus, worked in Microsoft, now working in a Capgemini, and he has been always with us and when it is as and when it is needed when it comes to delivering the lectures. He's so passionate, and he, as and when we call him, he always accepts our invitation, and we're proud of him being our alumnus. So I'm here to introduce him, and I got an opportunity, and I'm privileged to introduce him. So Mr. Mukesh Jain is a Chief Technological Officer and Executive Vice President at Capgemini, renowned for his visionary leadership in technology and AI-driven innovations with 30 years of industry experience. Can you believe 30 years? Right. He holds unique expertise in a mix of technology, global business, AI, analytics, management, execution, and people management. My voice is clear, Kapre madam?
Yes, sir. Yes, sir. Yes, voice
Thanks,
is
Yes,
clear.
sir.
thanks, thanks, thanks. Right. uh, he has orchestrated global initiatives in AI-driven product innovation, development, analytics, machine learning, IoT, people analytics, sustainability, setting new benchmarks in the digital transformation. Mr. Mukesh's career includes pivotal role at leading organizations like, as I said, Microsoft, Geo, NICE, VPS Global, and where he led a groundbreaking projects and established centers of excellence that have impacted millions of users worldwide. Mr. Mukesh is widely recognized for bridging the technology and the business, driving strategic innovation that delivers the tangible business value while fostering the human progress. He frequently shares his expertise as 4 times TDX speaker, executive coach to 15 CXOs and business leaders, startup business advisor, adjunct faculty, and advisor to 18 universities, including the IITs, IIMs, BISP Learning, and several others. He holds master's degree in software system with specialization in analytics and business intelligence from BISP Learning, and has authored 2 books on cutting edge technology. And I'm proudly say he has completed his graduation from this very institution, MCM's College of Engineering. So can we all clap for him for having, the proud alumnus from our institute. Digital clap I'm expecting, dear audience. Thank you so much. Yeah. Mukesh Jain's multifaceted leadership has earned him numerous honors, including the Visionary Award, City of the Year, and global recognition among the top 50 CTOs worldwide, making him a beacon of influence and inspiration in the tech industry. He's passionate teacher, and he has delivered over 6,400 sessions covering 740,000 learners so far in last 14 years after he returned to India. So thank you so much for this great contribution in this technology. And we are eager to listen to you, all our listeners. And this is the concluding session of this faculty development workshop. So thank you so much, sir. And I request you to please start your session. Thank you.
Thank you. Thank you, Titraji, and good evening to all of you. Jai Jinendra. It's always an honor to come back to MGM and do the session. And the couple of faculty development sessions I've done recently, one of the things I was emphasizing how we can use data. Hello? Yeah. Okay, I was emphasizing how we can really use data in education. And when Rajuga madam approached me for this session, I definitely said, yes, we'll definitely do it. And AI in education is very interesting because AI is near to my heart and education is near to my heart. So this is the perfect combination. And last session, so I'll try to keep it brief, even though I had planned for 1.5 hours. Because I think we'll have to finish it by 6:30. So I'll try to do that part. Try to condense the content. Irrespective, you'll still get the slides so that you can look at it if I'm not able to cover it. So I'm sharing my slide now. 1 second. Okay. So as Titra sir, I've already covered my introduction. Just briefly talk about it. Yes, I'm alumnus or MGM, proud alumnus or MGM. By the way, I've just finished 30 years this week, right? So just on the time, 30 years experience. 13 years, Microsoft, I was able to do 13 years, worked in US with multiple products, had honor and opportunity to work directly with Bill Gates and Satya Nadella. Came back to India, worked with Mukesh Ambani for 2.5 years for Jio, and a couple of other places, stint here and there. And last 7 years at Capgemini. I also had the honor to talk about AI very early in Microsoft for 1999. I'm sure as a faculty, each one of you know that AI has been around for quite some time, but most of the people in the industry knows about AI in the last 2 years and 9 months. I always wanted to become a professor, right? So when I came back to India in 2011, I approached 7 different universities. None of them gave me this opportunity to become a professor because I did not have a PhD. And at that time, I did not have a master's also. So I thought, you know what, let's continue my CTO journey. As an industry person, I'll do it. But at the same time, I didn't have a chance to learn at IITs and IIM, but then I thought, you know what, let me start teaching there. So IIT, IIM, BITS Pilani, multiple of those part, 18 university, I'm advisor. So bringing that element about how we can do the future for Bharat, future for India with education, and I was able to do that part. 2 books I published, third book I'm writing right now. Data. As Mukesh Ambani said once, data is the new oil. Okay. I worked with Mukesh Ambani for 2.5 years, defining the whole journey of Geo, what the vision would look like, and so on, powered by AI, of course. But one thing I always realize that we can do a lot of those things with data and all. But after I was looking at it further, I realized that if I keep calling data as the new oil, I may not get all the value, because we all know oil at some point will perish. At the same time, if I don't get the value of oil, I can still get the value tomorrow, but it is a limited supply. But if I call data as sunshine, ma'am, can you please go on mute? Thank you. So if I call it data as sunshine, instead of data as the new oil, if I call data as the new sunshine, what does that mean? In abundance, everywhere, right? For future also, it's not going to deplete. At the same time, we have to be careful. If I don't use the value today, it will be available tomorrow. So if I compare data as the new oil compared to data as the new sunshine, I think I'm getting more and more excitement that yes, data is the new sunshine. If I don't get value today, today's value is lost. Tomorrow I'll get it. Compared to oil, is not the case, right? So more and more I'm start believing data is the new sunshine. Okay. What is data? See, this session is AI in education, AI for Bharat. Right? But now, if I go deep into this piece, we'll be able to understand that it's all about data. Data, which is every activity or inactivity generates data. Look at any book, any reference material, any content. Majority of them will be talking about every activity generates data. I believe even inactivity generates data. I'm sure when you're going to faculty development workshops, so many of you, right? You all are active on the call, but you may not be as active on WhatsApp. And that is the data. That is the inactivity, which is also generating data. So data, when you talk about, don't look at numbers. Yes, data is all numbers, right? Normally we think data is numbers. As soon as I use the word data, an Excel file comes in front of you with columns. Yes, that is data. But yes, 96.1% of the data is images, text, audio, video, all of them are data. Huge amount of data. Let's take an example. I'm sure all of us have used voice to text translation. Now I'm giving a voice, and now let's see how the translation will work. Think about it, right? I'll speak in Hindi first, and then I'll translate into English, right? मैंने बोला ना नहीं करना है. Okay. Now this sentence in English, I told you not to do it, right? I told you not to do it. The same thing I'm in a different voice. I told you not to do this. मैंने बोला ना नहीं करना है, right? Look at the tone. The difference was very different. The first one was normal tone. Second one was aggravated, gussa, or a lot of the higher tone was there. I'm raising my voice. None of the system will translate that. It will only translate, I told you not to do so. That's it, right? That information is lost. Text, image, right? Mukesh smiling, Mukesh frown, right? All these things are also in data. Lots and lots of data is there, which we are not even capturing today. Okay, picture abhi baki hai, right? There's a lot more to be done in this area. That's why 96.1% of data is unstructured. How do I interpret? कहना क्या चाहते हो, right? What are you trying to say? The text conversion, that part, right? So when you look at the data, start biggest part, right? In education, as of today, it's been 14 years in India, and I've done lots of projects. As of today, probably I've done 14 projects, 1/4 project AI in education. Okay, while my lecture is, this one is 6,404th lecture, but the whole piece about how data can be used in education, including, right, assessment and all. We'll talk about some of the use case study today. Okay, the old part is intent, mansha, what's going on, what was it happening right now at that moment of time, to be able to understand extracting the information from data. So data is very powerful. You have to have it, but remember, data doesn't come automatically. You have to have measurements. You have to have specific measurements for data. So today, one of the project I did about 2 years back at one of the university in Mumbai, and the project was all about understanding the data about how much score people have made. Very simple, right? Each student, what is the score? Marks, how much they have got. But as soon as I go to the next level, which question, how much is the marks? I got some insights. Now when I look at the whole class, I can get an understanding about, what? Is student lacking that knowledge? Or is the teacher who was not able to teach that particular topic? Because question number 5, majority of them did not appear or got very less marks. That's the insights, right? So slowly when you start getting into data, you get more lot of understanding, right? Now the whole train, I'm just going to take another 2-3 minutes just talking about how to go from data to AI. Yes, a lot of people still think AI equal to Gen AI, but that is limited, right? We are just getting generative AI. But if you start with the foundation, you're a lot more ready to get full value out of it. Okay. So what is AI? It's a scientific process. The word scientific is important. Analytics is not just BI. Analytics is not just using some tool. It's a use of facts, data, and analysis, giving you an explanatory model. Explanatory, Q, Kaiko, why certain thing happens. Explain it. Once you understand this part, you're able to do better. So in education, same thing. If you're able to capture the data in terms of what happened, why it is, and then apply statistical model, we are able to predict it better. We all will be able to do it. Students will be able to do this even better with data. I remember my days in MGM Nanded, where I used to do this model about, how much I've studied, how much is spending. This much is the requirement. How much time I take to learn. Like even I was using the data part of it right in my college in 1991, right? To be able to see if I do this part, what marks I'll be able to get it. Like so having this part, of course, that time it was no Python, AI was not very popular and so on. Okay, so that was always a challenge. And then come machine learning. Machine learning. You're having the system, computers learn from those. I'm sure all of you probably know this already, but just to give you a little bit perspective, it's all about past data. It's all about input-output combination. It's all about coming up with the patterns and doing a prediction. Machine learning, there are 3 elements. Supervised learning, which is the most popular one. Using historic data, can I predict what will be the output? Because I have a combination of input and output, which is giving you supervised learning. Interesting one, not many people are doing it, is called unsupervised learning, creating clusters, finding out patterns, clusters of patterns. Is there something which you are missing out? Clusters, unsupervised learning. Why is it called supervised? Supervised because there is output also there. Unsupervised because there is no output. Then comes my favorite, which is reinforcement learning. Barely 1% of the industries are using this. Reinforcement. By the way, each of us, I'm sure, right? We are seeing the child growing, right? 1 year, 2 year, 3 year, 4 year. We all are using reinforcement learning. We are telling the kid something is wrong, something is good. Yes, good job, right? Good, reward, penalty, reward, penalty combination. Machine learning, if you don't have data, reinforcement learning works perfectly fine, right? Reinforcement learning is the future wherein you will be able to do fine tuning the model based on what response you get. And then of course, the whole journey starting from measurement. What is this? Getting those part, getting into data and then information, insights, predictive, prescriptive, all the whole journey part of it. So for us, when you're talking about in education, what are we teaching? What are they learning? What is the output, the marks part of it, right? But more important than marks is the knowledge. Are the students getting the knowledge? And the best one, and I keep talking to Titre sir also all the time, which is about how do you translate that into 20 people appeared for an interview, how many cleared it, right? That also is the insights, that data. And then you feed back to, okay, what can we do better in 3rd year, 2nd year, 1st year? Building the whole model about it, AI in education. By the way, if any of you are interested, would love to share more details after the session in coming weeks about how can we actually build AI in education for your respective colleges. That will be another interesting way to look at it, right? So your measurement is there. Your data is available. Okay. Now, people might ask, what is the difference between measurement, data, and information? For normal people, it's the same, but we are not normal, right? Measurement, what are the things you are able to measure? The output of measurement is data. Now, interpreting the data is your information. Getting the insights, what work, what does not work, comes into your part about insights. And then you do something to be able to create a prediction. And then you will be able to prescribe in what? from next year onwards, we are going to do this part. Okay, I see one of the hand is raised. Please go ahead. Please go ahead and unmute and speak. I missed the name. Shiv Prasad, what was it? Name? Please go ahead and unmute and speak. Somebody have raised hand. Okay, no longer. Okay, fine. Second. Okay. Then comes our favorite, artificial intelligence, right? Recently, about 7 months back, I was invited at an event where all Jain monks, Muni, right, who don't use any technology, who are just promoting the religion and all. They invited me to talk about AI. I was stunned. How would I teach? I will not be able to use laptop. I'll not be able to use the example of Amazon, Uber, or YouTube and all. How would I teach? Right. So all I did was talk about intelligence, talk about human intelligence, and then how AI comes into picture. Like when would you call a kid or somebody smart? When would you call somebody like the hushar hai, right? Intelligence, right? So the whole focus was intelligence. So let me talk about that. How does work? Simulation of human intelligence. That is your AI. Simulation of human intelligence. Yes, intelligence. When would you call intelligence? We call a person is intelligent, especially when we say, you know what, this particular person remembers very well. This particular person, that's a memory. This particular person is able to interpret very well. Yeah, translation. This person is able to solve problem very well, do mathematics very well. So if you look at start building this together, that's your intelligence. Is AI able to do all of them? Yes, it has started to do all of them, but they're not there yet, right? We all are fortunate to be able to write this particular wave about AI because what we are doing is we are using this for multiple element. Some of us are only using it to get ChatGPT some output. Some of them are actually building the AI system. In 7 years at Capgemini, we built several products in AI, which people are able to use it out of the box. And this is again, large language models are there, automation is there, a lot of these things are already there. The whole piece is learning. AI is also learning, right? Learning from us. The signals we give, they're learning from us without explicit programming. Okay. The piece which people miss out on AI is the decision-making capability. AI is taking decisions and we are using it, right? Now think about compare ChatGPT, Google. What is ChatGPT? It's a slightly better version of Google. Yes, slightly better than, right? How is it? When you did a search on Google, you got some output, thousands of output. Google said, here's the output, you figure it out. What ChatGPT did, here are the output, but I know what is required for you. So I'm condensing it, giving you the output the way you want it. It starts with that, right? But that's the interesting part. What is that done? ChatGPT have done a decision and given to you, right? I'm sure several of you probably who have traveled internationally, you would have gone to VFS Global. I was the CTO for VFS Global 8 years back. In that VFS Global, what I did? AI-based visa processing. Looking at your document, looking at your parameters, what is the likelihood that you will come back? What is the likelihood you will not do crime at the destination country? Giving the probability based on historic data, based on your signals which you're sending, right? Now, will AI make a decision? Yes, in case your profile is very clean and everything is clear, you go click, and boom, your visa is ready. Several countries allow those visa. In few seconds, you will be able to get your visa. And of course, several countries, it will take days and months and years in some cases like US and so on, because they're not using AI to take decisions and reasoning, right? So combination of this is giving you AI. So in education, definitely you can use a lot more on those parts because it's able to take a decision for you. And last part, self-correction. Okay. So I'll give you one example today and then try and see if you all of again you can use it. See, we have 110 people on the call, right? If all of you start using this, and very simple. From Monday, estimate when you leave from home to go to the college. Estimate how much time you're going to take. Okay. Let's have a quick one. So on the chat window, if you can put that answer, how much time do you take to go to your chat is not available. Okay. That's okay. I cannot see the chat, but it's okay. If you are able to estimate how much time you're going to take to go to the college, right? What are the numbers are? If your answers are 30 minutes, 15 minutes, 45 minutes, 1 hour, your answers are wrong, right? You can never be rounded answers like this, right? Normally what we do for simplicity, we just round it off half an hour, 45 minutes, 1 hour, right? But when you give this answer, I'm pretty sure that you're not going to reach in half an hour. You're given the ballpark number, you'll take 40 minutes or even 20 minutes or so. But imagine if you start giving the answer, which is 33 minutes, I'll be there. 42 minutes, I'll be there, right? 1 hour, 3 minutes, I'll be there. People will be more conscious. They go, wow, the person is the estimated part, right? I'm not talking about looking at Google and map and talking about it. Estimate. You do that for 5 days. You estimate how much time it's going to take, and when you reach college, write it down. What is the measure? The measure is when you keep your right leg out of your home. And the other measure is when you swipe either a biometric or you swipe your card in the college, that's the time you need to capture. Guaranteed in 5 days, your accuracy will be more than 95%. Right? Because humans are very good at self-correction. Self-corrections. So you estimate, fine. Estimate, fine. You fine-tune. And then you can use your own thing. 2 minutes plus or minus, 3 minutes plus or minus is okay. And boom, your 95% accuracy is there. So when you talk about intelligence, the other intelligence is pattern matching, right? Now look at it. Everything, I'm pretty sure, without even telling you, you will say everything is A. Obviously, right? All of them are A. But imagine if I gave you only this one. I'm pretty sure you will not call this as A. In fact, you will call this as H, more H than A. Okay. In fact, you will not even talk about A. You will say just a design. Right? So all these things, even this one, you will not call it as A. So because I've given you all of them together, you probably will call them as A. That's what AI does. It looks at the history of looks at all the parameter which you supply, along with the parameter which says this is A or this is not A. Same thing, right? When you're looking at the marks, when you're looking at somebody's response, you're looking at it and trying to find out, is this the person really knows the concept or not? The ability to predict based on the data to be able to, for the new one, is what is called an intelligence. So the interesting part comes in here when you're looking at it, computational, automation, intelligence, and now we are talking about cognitive. So the whole journey started in computational maybe 5 decades back, 4 decades back. Automation, last 3 decades, we are talking about automation. Last 1 decade, we are talking about intelligence. And picture abhi baki hai, cognitive part, where system will be able to think like people. And this will be the future, the real future, wherein cognitive. Today, as a CTO for AI across the globe in Capgemini, in 7 years, I think I would say I met so many CTOs across the globe. People are still struggling to get there in intelligence. So last 10 years, we are talking about intelligence, but people are still struggling. I think I would still say people still long way to go to cognitive part of it. Okay. So let's take 2 examples, and then I'll jump to some of the specifics about using AI in education, including case studies. Industry recognized case study. And I was doing some research last week to prepare for this topic. And I found out that several tools are already doing things which we want, right? Of course, the 14 projects I worked on, multiple colleges, university, where we implemented this, it was a process of collecting the data and everything, a lot more sophisticated compared to some of the out-of-the-box tools which are available right now. So let me take some example. And the purpose of the example is thought process. In your education, what all thing will be doing? So you saw this dialog box. You have been seeing this for last 20 years or something. Okay. And what was this? Send error report. What was send error report? Data. I want to collect data to see why the product is crashing, why Microsoft product is crashing. That's it. Collect the data, right? Code, scenario, why was it crashing? And then you do analytics. Remember I said measurement, data, information, insights. So this is the measurement. How do you collect? Measurement. I got the data, then I can get information. Oh, this crashed because of this reason. You get the insights and you prevent the crash from happening. So for education, you're collecting the data part of it. Okay. Now here's another interesting part. As I mentioned, every activity or inactivity generates data. Now here is an example of junk email. Bill Gates. My first interaction with Bill Gates was 1999, about 3 months after I joined Microsoft. He used to get 15,000 junk email per day. 15,000 is a lot. I know we get 10 junk email and we get upset, right? 15,000 is a lot number, right? And we were trying something. And then, of course, I raised my hand. Puchne mein kya jata hai? I raised my hand and saying, I want to solve the problem. I was told, no, I cannot, because I didn't have PhD and I was very junior in the company. Now, here is the algorithm. AI algorithm, very, very simple algorithm. Instead of focusing on the email type, What is the junk? Oh, unwanted email. Of course, it's unwanted email. But how do you know? How would computer know whether you want it or not? Because sometimes you open Flipkart email, sometimes you don't. Sometimes you like those phone calls, sometimes you don't. How do you determine? So here's my answer. Divide into 3 segments. Okay, which is first one was, are you going to read an important email for more than 5 seconds? Answer is no. So more than 5 seconds, less than 3 seconds, 3 to 5 seconds. What am I doing with the email? Am I reading it? Am I deleting it? So anything which is less than 3 seconds, I'm deleting, probably is junk. Anything which is more than 5 seconds, or I'm reading it multiple times, not junk. And anything in between, evaluate. That's it. What am I doing? Collecting data, collecting data, collecting data, collecting data. So now measurement was done, collecting the data, getting the insights, and start predicting. Predicting. Oh, looks like this is happening. So when I look at the student and the kind of marks they have got, when I look at the curriculum and I see, I'll be able to say, okay, fine, what data I'll collect for this curriculum? Assignments, question, quiz, multiple format, of course, you'll be able to do that part. 94% accuracy I was able to achieve on Bill Gates' mailbox within 1 week, just by doing this part. And you can imagine how simple this is. Get it, process it. Oh, Flipkart email, Mukesh delete in less than 3 seconds. But Amazon email, Mukesh is reading it. Important email, he will not delete in less than 3 seconds, right? Repeating 2 times, 3 times, I'm seeing the same email. Of course, this is important. All those parts. Okay. And the last one, before we take other examples, when doing search, you might have noticed the links are blue in color. Blue. Why blue? A curiosity. We all are born curious. As humans, right from 1 year age, the kids, everybody is curious. The question here is, they'll ask, what is this? Why this? And the answer always we give, मैंने बोला ना ऐसा करना, इसके लिए ऐसा ही करना है. Why? Why should we restrict it? Right? And that's the challenge. Because somebody said so. The curiosity is lost. When I asked this question as a curious person in 2006, why the links are blue in color? The head of Microsoft Bing told me, oh, that's blue because the blue is color of trust. Trust, of course, trust, good. Why this shade of blue? This is different shade, this is different shade. There are so many shades of blue. And then came the interesting element. Is the Mukesh, what's in your mind? I said, I want to check which shade of blue will give us better results. Of course, money, right? Better results. We ran an experiment. 10% people were given one shade, another 10% another shade, another 10% another, 10 different shades of blue, 10% got different shade of blue. Boom, ran it for 2 weeks. 2 weeks, 9 darker shade gave us better results. Wow, right? You are able to see if manipulating the shade of the blue, you're able to get better result, better money. Okay, now here, again, data, machine learning, and able to use AI part of it, and then doing it. I remember an old movie name, Dulhan Wahi Jo Piyaman Bhai, right? English translation of the Hindi translation of the word personalization, right? If people love this shade of blue, why are we changing it? Mera wala blue, mera Asian Paint advertisement, mera wala blue, right? My favorite shade of the blue. No, it's all about Dulhan Wahi Jo Piyaman Bhai. It's all about personalization part, and that is exactly what the search part is. Okay, and the last part. If you look at it, right, there are multiple examples. I'm not going to go through all of them, right? But if you look at it, like so many times, like when you're booking an Ola or Uber, how do you determine whom should be given, which app on content to be showed next, and so on. So many of examples are there, right? And we all use it every day, all by AI. Now, same thing if you apply in education, is it possible? I'm not talking about just commercial Coursera, do one course, 10 other courses get bombarded to, I'm not talking about that. But I'm talking about looking at the preferences, looking at what Mukesh really like. Mukesh's learning style. I did a faculty diamond workshop at BITS Pilani a few months back, and I was always talking about, can we personalize? And today I have an example of that in the education section. Can we personalize education for people? So when we talk about all this, let's talk about some of this major element, which is inclusive accessible education through AI for all, right? So when you're talking about Bharat, when you're talking about India, right, across, how people can access it. It's still unfortunate we are having the session in English, and that's because that's becoming a more common language in India, right? But imagine as kids at early age, they're more comfortable in their mother tongue, right? Can we have the education in mother tongue, right? Yes, possible. But then in that case, now we always have a question: will they be able to get a job? In the language is not strong, right? Irrespective, fine. I'm not going into that debate. Let's go back to English, right? When you're building this species, right? How easy is it for them to learn, right? So let's talk about this, right? So remote, right? Remote underserved people, right? Can we deliver this session on for those? Yes, of course, you can do that part, right? Multiple language, right? All AI, when you look at the AI platform, can we build this part so that we can do remote underserved areas of Bharat doing this part? If anything else is there, COVID at least helped us be more and more digital, right? As mentioned, right, I've done 6,400, this is the 6,404th lecture mine, right? But I can tell you that out of which about 30% of the lectures were online. 30%, right? Now, when I do online, the outreach is very well, because for me, I need to commit that 2 hours. The 2 hours I could have been watching a Netflix movie, but I need to commit that 2 hours, and my lectures can go across anywhere in part of the world. Compared to my physically traveling there, doing this overhead and everything, it will be 2 hour session. I will have an overhead of at least 1 day, if not more. Okay. Now there is a Vande Bharat train from Mumbai to Nanded. I'm pretty sure I'll be traveling more to Nanded because the connectivity have improved. There are flights between in and on and off, but yeah, the connectivity improves. Definitely we'll do more session like that, right? The whole part is about infrastructure challenge, right? Connectivity is always a challenge, right? Physical infrastructure, remote access, learning resources, all of them will be important part. Personalized path. Everybody have their personal learning style. I was never good at remembering stuff. Never, right? History was always, I used to hate it. And I don't know, barely used to pass. Mathematics, yes. I used to have a high bar for me. It was very interesting. Once I got 97 marks in mathematics, and my dad, instead of celebrating, he asked me, where did you lose these 3 marks? Of course, it took, can you imagine, it took some beating and everything, and it take some time to get there, right? But my daughter, when we moved back to India, she was in Bangalore, and she came first in India in mathematics, 100% marks. Okay, and her name comes in Times of India, right? Proud moment for all of us, right? But what was it? Personalized learning part, personalized, right? If Mukesh, if my daughter, if anybody prefers certain subjects, why can't we focus on those subjects? No, in the job, you will have to learn other things also. No, not right. I was in Sonipat last week, and I was visiting one university, and I look at the syllabus. I asked them, why are you having physics? They said, oh, because people will need robotics, and for robotics, you need physics. I said, fine. Why are you not having cloud? Oh, we don't need to have cloud. Why are you not having RPA? Oh, we do. They had 7 subjects with missing. One of the university in Sonipat, last week I'm talking about. So what happened is you're trying to optimize certain area, but you're not missing out on other areas. Again, the main point is how can we have the syllabus or the content which is a lot more relevant as of today? We should always have this part of 30, 30, 40. 30% should be foundation, which you want everybody to learn. Foundation, yes, there are a lot of foundation element we have to make sure people are having it. The next 30% is something which is on your skill. We want people to have it. And then only remaining 40% should be on job. Like we want to make them job ready, right? But what has happened over a period of time, more and more focus, and 90% or even 100% is becoming this part, which is a challenge because the skill or the foundation will be missing part of it, right? The skill-based education is all about that. Specific competency. Today, when we hire people at Capgemini, right? We are hiring people at a variety range. Minimum, let's say when we talk about it, we are having people with 2 lakh salary, mostly MCA and BSc IT and all, 2 lakh salary. And then we also have people who are hired at 30 lakh salary. Both of them are fresher, 2 lakhs to 30 lakhs. Huge range. Why that huge range? Because the other person here, probably from premium institute and able to becoming productive day 1. But the skill requirement are almost the same. Are you able to solve problem? Do you have data focus, AI focus? Part of all of those things are there, right? But the thing important comes in the way they communicate. I'm not talking about English, but the way they communicate, the way they articulate, the way they take the problem statement. Here I'm seeing more and more. एक बार मैंने commitment कर दिया, खुद की भी नहीं सुनता. More commitment, more accountability part of it, more passion to do this, asking 10 questions. Compared to here, आप बताओ क्या करना मैं कर लूंगा. It's not bad, but still, आप बताओ क्या करना मैं कर दूंगा, which means you're asking for the inputs, give the inputs, मैं क्या करूँ, नहीं हुआ तो मैं क्या करूँ. Right? Look at the attitude, the skill, the more and more demand for soft skill come into picture. Yesterday, there was the event of I Am Jammu in Mumbai, and I was speaking on that event, and I talked about it, right? There are 44 skills, soft skills. 44 soft skills are there, and we barely see 4 to 5 soft skills in students. Can we build these 44 skills in those students so that they are fully ready, not just to crack the interview, but then do a good job at the job? Because everybody, every student, every college is eligible to get to the 30 lakhs package. But how do you enable them to get there, right? So how do you do the strategies, right? So the old part is equitable. Right. So of course, there are a lot of CSR budget for a lot of corporates. Even we do digital part, digital inclusion, which we call it. So what all these colleges in remote areas, right? We talk about interiors of Maharashtra, interiors of Karnataka, interiors of UP, Bihar, right? So all these colleges, right? They probably are having some professors are talking about it, but then are they fully ready? So making the part of faculty, like the learning party, this faculty development workshop like this. Thank you to Raju madam to organize such a things. But this will be the main part to drive better education for all, right? So the whole piece about how do you have equal access to education for people, identifying the gap, right? I would say have taught at so many universities in India and being advisor at 18. I've seen it's not very much difference. Faculty is there. Most of the faculty I've interacted, they have passion to learn. It's just that they don't know what to do, or it's just that they are not giving the exposure part of it. And that's where the resource allocation, optimized resource allocation become more and more important. So let's take an example. This is a very interesting one. Some of you may have know about this Dreambox Learning Impact. This was primarily done for mathematics, right? So what the company Dreambox did, the whole focus for them was how can I improve the math lesson dynamically for individual student responses, right? What it is doing, so 3 parts of AI. A lot of the content is available. They do it and they try to adapt. Okay, so what they will do first, they will put some questions. So that's the first part of it, which is content creation. Okay, second part, look at the student learning part, learning speed, learning responses and all. Understand those speeds and say, you know what, Mukesh is good at that. Mukesh is not good at that. Mukesh is good at solving problems, but he's not good at remembering stuff. It understands those parts. And the third one, try to do this part and take that to that level for the person to go deep into this, right? I don't know if your colleges already participate in competitive programming. My son is the expert in that area. He's a worldwide top 10 ranker. I think last year he was there, and now working for a company called Databricks in Bangalore, one of the very good upcoming promising company with a very high salary package. But how did he get there? Mathematics, right? But then for him, of course, he didn't use Dreambox or something. But for him, he was like, you know what, Dad, I only want to get into this area. Sure, Russian mathematics are there, Singapore mathematics are there, right? Which are very, very advanced. So can we identify? Because for engineering, when you talk about it, especially for AI, it is all about mathematics. It is all about mathematics. The foundation has to be mathematics, right? So this part, adaptive part, helps you do that. So I'm a default mentor for a lot of people. So a lot of the CEOs' kids across India, they approach me, okay, Mukesh, can you help this person do internship? I said, yes, I can help this person do internship with me. They are in second year, third year, final year engineering. But I said, you know what? You could have started early. So I encourage people who are in 7th grade, 8th grade to start early in terms of adopting mathematics. I'm not talking about AI. I'm not talking about jobs. I'm talking about mathematics. Foundation part of it, right? Improving math proficiency. So Dreambox is a good example because what they did was the AI platform which they created, okay, they focus on measurable improvement. Now, very interesting part. Let's say if you are appearing for an exam and you're preparing for it, IIT, the standard one, right? But there's so many example things. And there are 10 questions, multiple choice. I've done it. I'm sure all of you have done it. Multiple choice. So you'll answer some of them. Some of them you have no clue. So what do? You do best estimate or judgment or tukka lagana, right? Or you bluff the answers. Sometimes it works, sometimes it doesn't work. And you got the answer report. Remember, and of course, it was a practice session, assume. Let's say your bluff went right. Okay, and done. 2 days later, I give you exactly same question paper, exactly same question paper, and then ask you to answer again. You will not remember the bluff, and that part is not taught to students. Yes, you will bluff to get answers, fine, but who are you fooling? You are fooling yourself. At least in the practice test, don't bluff. If you don't know, just say no, blank, and that's why you learn better. And this is exactly what it is doing. The platform. I had the honor to evaluate the platform a few months back, and I saw this part very well done. What it does, it is doing measurable impact on math skill, and specifically looking at the part where you have not answered. And this is the differentiator part, data, right? How does it do that? It does real-time analysis and then give you personalized feedback. Mukesh, these are the area you are not good at. You might want to improvise. You might want to learn this content and all. This piece about personalized recommendation, personalized improvement part is very, very key here. How you'll be able to teach. And this is again a good case study.